And also you can see some injection wells. These are all some of the ways by which we can improve the groundwater recharge. And here you can see a spreading ponds. Here is a recharge well, and here is a percolation pond. These are all some of the ways of nature-based solution to improve groundwater recharge to enhance the groundwater quality. So these are all the case studies which I would like to quickly run through, maybe a couple of slides under each. One is dug well recharge to improve groundwater contaminated with fluoride. Similarly, check dams to reduce fluoride contamination in groundwater. Third is in saline aquifers, how a percolation pond is able to have some lens of fresh water, then riverbank filtration, check dams to mitigate seawater intrusion, and last two are our recent case studies. I'll quickly run through this in the next 10 minutes. First is the high fluoride groundwater. These are all the locations in which we had carried out studies in the last 10 years, right? Starting from Telangana, some part of Karnataka, 2-3 locations in Tamil Nadu. I'll focus the work which we have done at Tamil Nadu. Here, the concentration of fluoride in groundwater is above 4 milligram per liter. 1.5 is the maximum permissible limit. So people are affected by both dental as well as skeletal fluorosis. So what is the way forward? We thought whether managed aquifer recharge will help to improve this problem. So we did a small study, right, with a pilot of a recharge structure, something like what you see in between existing dug well and a collector area. You can see about 1.5 by 1 meter dia concrete pipe was used with the kind of filters, right? Both the coarse and fine sand in between. One chamber was left free. What will be the benefit which we will get out of it? We constructed this as a part of this guy's PhD work. Right. This is the picture show the construction. After the construction, you can see there is a tremendous improvement in recharge, right? For example, you can see at the center that red dot is the place of our intervention. Over there, groundwater head is much higher than the surroundings. That means, though it is a small structure, it has formed a kind of a mound and the water is being recharged to the surroundings. What happens to the quality? So here is a picture, right? That is the vertical line there in the date of our intervention. During the next year, you can see that the rainfall at the bottom. The rainfall was more or less the same in the subsequent year too. In fact, it is little lesser, but you can see the green line where the groundwater level has raised at least by 4 meters after the intervention. And the electrical conductivity has decreased. On the top, you can see the concentration of fluoride has come down to 1.4. This is the benefit which we could get out of a simple intervention made at this particular site. However, I am not telling the background, right? The enormous 3-year-long hydrogeochemical study which we carried out to select this site. And we monitored the same site for nearly another 4 years after our intervention. This is the long-term data. Here you can see the top red is the fluoride concentration. It remained always below the permissible limit. So this is the first study. Then similarly, at a nearby site, there was a Nalla wherein we had gone ahead and monitored the efficacy of a check dam in improving the groundwater quality. So on the right-hand side, you can see a picture where, I hope you can see my pointer, right? The red is the electrical conductivity of water in the check dam. Obviously, it is a fresh rainwater, so quality is far better. So when you see on either bank of the river, the quality of ambient groundwater is much poorer, right? So this shows the recharge from the check dam retained water will certainly improve the quality of groundwater, adjacent groundwater. Similarly, if you look at the fluoride, even beneath the river, when the river is not flowing, concentration of fluoride would have been somewhere here. Since the recharge takes place, this also improved the groundwater quality in terms of fluoride at this particular site. Right? And more or less the same, I'll skip this. Then the next is a percolation pond, just north of the city of Chennai, where the aquifer is completely saline because of the marine transgression. Right? People were very much affected for lack of water supply. Over there, we had an intervention. On the left-hand side is the percolation pond, which we have constructed as a part of one major research project, as well as the community initiative. First, we constructed the recharge pond. The benefit which we could get was minimal because of the geological conditions over there. We had both sand and silt mixed, so the recharge was not really significant. Then for the subsequent year, we went ahead with a recharge shaft at the center here. That means like an inverted well with a perforations at the top from where the water can directly go into the groundwater zone. So that is the picture showing construction. After the construction of the recharge shaft, this was our first year of observation only with the percolation pond. In the subsequent year, after the construction of recharge shaft, the recharge has at least doubled, right? So this is how it has improved the groundwater condition. Realizing this, whether the water which got recharged can be retrieved by us later on, because beneath the surface it is almost like seawater because it is very close to the coast, and also it is an area suffered due to marine transgression, right? Then can we go ahead and retrieve the water that got recharged? So then we tried this aquifer storage and recovery, right? We have recharged the water through the recharge shaft. Subsequently, little later, we can withdraw. How much of water can be withdrawn? Can we go for a motorized pump? We did a numerical modeling study. This is one of the results. Right here, you can see the bubble at the top is the fresh water. That is the blue or bluish pink color is the fresh water. Rest all is the bottom red is completely saline. So since the saline water is a little bit denser, the fresh water formed a lens which cannot be tapped with a motorized pump. So then we went ahead with a simple hand pump that was able to supply nearly 250 liters per day. The amount is very minimal, but it was able to give at least fresh water for cooking and drinking purpose for the community which was living around this site. Right. The next is the study on riverbank filtration, right? So can riverbank filtration as an alternative to meet rural water supply in a place which is about 70 kilometers northwest of the city of Chennai, right? Wherein an intensive study was carried out much before the construction of the check dams, right? The completion was sometime during 12 or so. We commenced our study from 2010. So construction of the check dam will lead to storage of water on the upstream side of the check dam for 3 or 4 months, rather than withdrawing water from the check dam for water supply, which is heavily contaminated, especially with regard to microbial contents. So we thought of riverbank filtration well. The schematic sketch is shown here. That means a well adjacent to the river can be pumped. So it is a nature-based way of filtering, right? Rather than going in for the traditional sand filtration, automatically the water gets filtered. So we went ahead and found out the benefit of the check dam is certainly improving the chemical quality, as you can see here. That is at the center is the TDS level electrical conductivity in the river water. Adjacent groundwater also getting benefited where the electrical conductivity get reduced. But on the other hand, on the right hand side, you can see the microbial colonies are much higher in the river water because people are using, there are temples around, due to which it is very much contaminated with regard to microbial load. So on the other hand, on either side, the microbial load gets very much reduced because they're due to the natural filtration process. Then we went ahead and studied what can be the ideal distance at which the filtration can be almost 100%, right? So using some groundwater flow equations, we found out what will be the ideal distance. We found out if the wells are located at a distance of nearly 350-400 meters away from the storage area, that the day of transmission, that is, if the water goes for nearly 60 days through this sand filtration, it is almost devoid of any microbes. So this is another study. Then the last is on seawater intrusion. So here the whole country, we are suffering due to seawater intrusion. Seawater intrusion is the lateral entry of seawater into the land due to overuse of groundwater. Adding to that, we are also facing sea level rise. As the sea level rises, the extent of intrusion will also increase, as you see in this picture. Very common in coastal areas. This also leads to freshwater scarcity, including the city of Chennai. We did a study based on the observed groundwater level, decadal variation in the groundwater level. What you see on the left-hand side is during the peak summer, May, what is the variation in the groundwater level in the coastal part of the entire India, right? Based on nearly 1,200 observation wells of the Central Groundwater Board, right? Then we compared that after a decade. So we could find out the area where the groundwater table is below sea level has increased considerably, right? The picture doesn't speak very clearly, but this will indicate you very much more clearly. You can see 0 to -2. That means when the water table is below sea level, it will certainly invite seawater to intrude further. So that area has increased. So nearly by 400 square kilometer of area has been intruded by seawater within 10 years. So what is the way forward? When we focused at Chennai, Chennai is also suffering. This is the map just north of the city of Chennai. City of Chennai is somewhere here. And here is the alluvial aquifer, which also supplies nearly 5 to 10% of the city's water requirement. This got heavily salinized. Here is the variation for a long period, right? We got the data from Metro Water. From 87, we have been monitored more or less frequently. So this is how the concentration of sodium varied in groundwater. This is the coast towards inland, right? This on the right-hand side axis is the coast, and this is the inland part, right? Concentration of sodium, it was initially somewhere here 69, sometime during 10 years ago it was here. This is the chloride concentration. Similarly, spatially, the old one is shown in black color. For example, if you look at the chloride, I will read, the concentration of chloride was only about 700, 800 here, but nearly 8 years ago, it is 7,000 milligram per liter. So this is one of the worst affected area due to seawater intrusion. What can be done? So we thought of going in for check dams. Thankfully,
Professor Rengo, if you can kindly wind up.
Yeah, so thankfully, they have the 15 check dams have been constructed. At this site, the check dams were very much beneficial in improving the groundwater quality. Similar to the other one I said, the concentration of sodium in the water stored in check dam is only 50, whereas in groundwater it is much higher. So check dam is really improving the groundwater quality. Then we extrapolated the study which we have done at this site for the remaining 15 check dams, which construction of them is already over, using an integrated model. The model indicated, right, in 2015, this is the status. By the end of 2030, if they benefit from all the check dams, will push the seawater intrusion toward the seaside by at least 4 or 5 kilometers. I think that is it. I would like to share some of our recent work in which we are involved in this work of $1 million drops initiative in Bangalore, wherein 10,000 recharge wells are under construction. We are also helping this United Way Bangalore in achieving the target of improving the groundwater potential in Bangalore city. Then lastly, so much we will gain. And lastly, I will also like to say that we are also working with the CDD in going in for nature-based solution to improve the groundwater quality in a saline aquifer system of Ramanathapuram, as you can see from the Google image. That is it. I would like to thank you all. With the conclusion, right, aquifer recharge enhances groundwater quality, but not always. We have to be also very, very cautious. As rightly said by Saha Saab in the morning, right, enormous recharge may also change the geochemical process considerably. So it improves groundwater recharge. It helps in mitigating floods, and clogging and maintenance is a major challenge. So quality of water recharge is a big question mark. Still we don't have guidelines as said by Gupta ji in the morning. Thank you so much.
Oh, thanks a lot, Professor Rengo. Yeah, I would like to really appreciate that you stuck to time. And we have time for taking up a couple of questions. If there is any question to Professor Rengo, he'll be there to respond. Yeah, there's a question. If somebody can provide mic to this gentleman. Yeah, he's bringing mic. Yeah, you want to. Please introduce yourself first.
I'm Jan from A3. I work as a research associate in the Water and Soil Lab. So when we do our research, this is also one of the biggest problems which we face. There is no standards from government considering discharge standards or groundwater standards. So my question or suggestion is, instead of waiting for the government to come up with a standard, can all the academic institutions come together and bring up a standard for discharge standards to lakes and water bodies, and also groundwater standards? Because I think if all the academic institutions come together, there is enough
Yeah, I
resource.
think we got the
Certainly.
question. Thanks a lot.
Yeah,
Over to you,
certainly,
Kaushik.
certainly, it's a good suggestion. We can work towards that. But coming out with a standard for such a large country is also very difficult because it depends very much on the hydrogeological conditions at a given site, depth to the water table. There are many issues, but it is a very good suggestion. We can work towards that.
Yeah, thanks a lot.
Thank
Is there any other question? Yeah, we'll take up last question.
Yeah, this is Madhuri here from Pani.Earth. It's a citizen-led initiative. My question is about, I mean, it's really nice to see how fluoride levels have been improved, all of that, but what about the persistent pollutants? Have you looked at?
Absolutely, absolutely. We had a look into persistent pollutants, but we have not come across at this site because this is a very carefully chosen site in agricultural area where, usually in agricultural field, they will have a small area for drying of paddy or something like that. So we had chosen such a carefully selected site. But certainly recharge, as I told you toward the end, has to be done very, very carefully. It can have an adverse impact too. Even if you recharge very good quality of water, as Saha Saab said, if you recharge very fresh water into an aquifer, which is already having a kind of saline water, this will change the way in which the chemical reactions are taking place, right? Saturation levels may change. So it has to be done carefully and continuously. It has to be monitored. Even the fluoride study we did for nearly 3 years, continuous monitoring, then we chose a particular site.
Yeah, thanks, Professor Lungo. I think
There are some questions you can.
yeah, I think we will take up the questions maybe during tea time.
Thank you so much.
Yeah, thank you very much. And in case we are left with some time, we'll take up question. Thanks a lot and very nice presentation. And the questions were very, very interesting. Over to you.
Our next session is online by Dr. Sundar Rajan Krishnan. Sir is the Executive Director of Indian Foundation and an Ashoka Fellow dedicated to addressing rural drinking water challenges in India. His pioneering work in water quality has led to innovative solutions for mitigating fluorosis and improving public health. He also advises national and state level bodies, including the Ministry of Jal Shakti, and is actively involved in shaping water policies. We look forward to your session, sir.
Yes, Sundar, welcome. Yeah.
Thank you very much, Pavan. I'll just quickly share the presentation.
Sundar, I request you kindly complete your presentation in 15 minutes.
Oh, sure.
Thanks, Sundar.
Thank you, everybody here, for allowing me to present online. I hope my voice is coming through and also the
Yes.
slides are there. Yeah.
Your presentation is also visible.
Okay. Thank you so much. I'll be talking about water quality issues specifically and with respect to rural areas in the country. And in my presentation, the focus will be more towards looking at the drinking water quality contaminants. There'll be an overview, and then I will go into some early work that we are doing right now, mainly to share it with this audience and also to get feedback on what research that we could do on these experiments and how we can collaborate with more people in this group to explore more into these directions. So first, I think Professor Ilango also mentioned before me, the presence of these contaminants in groundwater as well as surface water means that safe drinking water assurance is far from being achieved, right? Even though a lot of different programs and well-meaning programs are being conducted, we are still finding contaminants of various sorts, right from those which are relatively well-known to new and emerging contaminants. As here we heard from one of the participants from Pani.Earth, Madhuri, also a question about new other emerging contaminants also which are persisting in the environments. Very briefly, why these are happening, why this contamination is happening. We might see water which is very clean to see and to also to taste or to smell, but then we might find that there are invisible contaminants all across. Largely because our country, rural areas are mostly groundwater dependent, but there is a lot of geological diversity within the country. So geologically, there is a strong determinant of these contaminants. and waste management from agriculture, pesticides, agrochemicals, but also new persistent chemicals which are even there in the rural environment. For example, the inroads of industries such as washing machine industry means that detergent chemicals are also there even in rural areas and accumulating in small ponds. But additionally, what I will also share here is also that it's not just a drinking water problem, but it is also a problem for food production and also increasingly for animals in villages. I will not focus too much on that, but I'll be happy to interact with that. This is a very basic mapping which is being done across the country using district level data. Largely, it says that there is a lot of diversity. You find high iron and arsenic areas in the belts, the Indo-Gangetic Brahmaputra belt. But you have also pockets of that in, for example, in Karnataka, due to totally different reasons. Nitrates are all across, but they don't come as like the top contaminant in any district. But you find, according to reported data, but you find fluorides in the northwestern, southern parts, but increasingly even on banks of Ganges in UP, you find fluoride contamination. So it is now becoming a more of a widespread and prevalent problem, many of these across the country. Even in hilly areas nowadays, you're finding, even though earlier as it was known, like arsenic is a plains problem, you are finding in odd places. So that way, even the existing problems are getting quite widespread. New emerging problems, such as uranium, for example, closest to where you are is Chikbalapur, where you find uranium in water, and very surprisingly in shallow aquifers is what you find. Recent papers have tried to summarize why this is happening. There's an index which puts together these contaminants, and I don't know if you're able to see it clearly, but the reds are the places in India where you have the higher presence of these contaminants, where the contaminants are weighted with more public health impact. So, for example, fluorides and arsenics are more weighted more than nitrates and salinity. And you find that some areas are more emerging in terms of a higher contaminant threat, and some are already prevalent with a very high degree of intensity. Having said this, also summarizing here in a bit in terms of it's not just drinking water, but also agriculture, with our estimates of around 9.5 million hectares of area irrigated being affected by either high fluoride, arsenic, or salinity. And it is because soil and food, and because of this, soil and food are also accumulating contaminants over time. These are calculations that we have made using various surveys and public data. We'll be happy to share more information about this. Now, because of this, what is the consequence? So there is a recent study that we have been conducting, and just presenting one brief idea about why this is important, why looking at contaminants in rural areas is important, not just from drinking water, but also food perspective. And that is why solutions, especially nature-based solutions, are needed not just for drinking water, but also for soil and food. And that is why I'm presenting this slide. This is an analysis of food grains that we have done across locations in different states. And we are looking at the consumption of these food grains by the population, and thereby a quantitative chemical risk analysis. Also a cutoff threshold for what is the maximum daily intake of this particular contaminant fluoride by people. And we see that in 2 places out of the places that we have sampled, the risk of having skeletal fluorosis, which as you would know is a highly debilitating disease, is as high as even close to 70% in one of the areas, just from food. So this is not drinking water, it's just from food, and just from the staple food grain consumption. And the reason why I present this is because solutions are needed not just for drinking water, but also to look at a holistic perspective of how we address water contaminants as a whole, and why we need water safe communities as a whole, not just for humans, but also for animals in terms of drinking water, irrigation needs, but also wider needs in terms of protecting soil and food from contamination. With this as a background, I come to 3 issues, and I'll be just putting forward 3 possibilities as examples to address 3 broad issues that I think there are more also in terms of rural contaminants, but 3 broad issues. One is to secure safe water, not just safe drinking water, but also safe water as a whole. Secondly, the large issue of sludge or reject water. As we know, I mean, in Karnataka, where you are, like RO plants are everywhere, and then the reject from these plants are also going around everywhere. I mean, what can we really do about it, and what can be solutions, for it? closing down these plants is one option, but then they are there. So what do you do with the reject water? Then third, as I mentioned, also safe food production in areas where the soil and water are both contaminated with high arsenic or high fluoride. Then what do you do about it? You need some basic nutrition, and especially nutrition is important to flush out contaminants from the body. So what do you do for safe food production in these areas? So I'll quickly come to three different examples. The first example is arsenic, three different approaches. The first one is for getting water safe from arsenic, and a process and a method which is gaining popularity now, and we are seeing good results from it. The second is an example of what we could possibly do with reject water from RO plants and high salinity water. And third is safe food production in arsenic and fluoride affected areas. I will quickly go through these three examples in the next two slides. I think possibly Lalitji from Sahel Foundation is also here, I guess so, presenting here in this session, as I saw in the schedule. So not getting into too much detail, but biosand filter is an excellent option for arsenic removal, and I don't know, I mean, why it is not widely practiced. But it basically involves, as we all are familiar with a slow sand filter sort of a process. But additionally, what you need is iron nails in it. So that's all. And we see the results here in terms of arsenic removal. The adoption and the promotion of a solution such as these in rural areas often is the the behavioral question, and also often is the larger question of initial cost and initial acceptance. So in our case in Assam, a specific district called Nalbari in Assam, the interesting part is that people are already using slow sand filters at home. And the reason why people use slow sand filters at home is because iron in water is very high. So what we really need to do there is a very basic retrofitting of what people do so that arsenic is removed. So this is a program that we have been running in Nalbari district in Assam for now last 2.5 years. And we see this as one possible solution for arsenic, which requires very less of interventions from any chemical-based treatment process or any other footprint on the environment in terms of using a biosand filter with iron nails, which needs to be replaced once in 3 months. I think if Lalitji is around, maybe he sheds more light on the details behind this process. An interesting possibility that emerged from people themselves, talking about it in terms of reject water of RO is that some varieties of palm and coconut are relatively more they are relatively more acceptable for high TDS or high salt inputs. That is what is now being used in some areas in Gujarat. I'm specifically talking about Anand district in Gujarat, where the total dissolved solids of reject water can be up to 2,500 or so from the reject saline water from the reverse osmosis plants. And as you see here, this is an example of palm, but palm and coconut, some varieties of palm and coconut, which can, for which you can have the input irrigated water of close to 2,000 or 2,500 also. So this is a second example I just wanted to put forward in terms of looking at salt absorbent varieties, of plants as where this is only the problem, and where you have other contaminants such as fluoride and others that adds and complicates the problem, but we don't have that over here. The third example I wanted to talk about was the food contamination problem, and therefore safe food production. The background behind this is that soil and food are both contaminated, and thereby, as you know, better nutrition is needed for ejecting or excreting contaminants out from the body. For example, for fluoride, you need better calcium, magnesium, and vitamin C, and similarly for arsenic and others. And then when you actually talk about basic nutrition and food production, even that water also has the same fluoride or arsenic and the same soil also. And as the food, the residuals that I showed earlier in previous slide, in the background slides. So what we are working on is safe food production, and we are using modular nutrition gardens or vertical nutrition gardens with organic peat and rainwater or treated water as an input, because the amount of water that you need here is much lesser than traditional methods of irrigation. You have plastics used here, and we are now we have a bamboo alternative to be doing modular nutrition gardens. You see that on the right. This is from Assam again, but this process is now being piloted across 4 states within our work, and we have been doing this now only for the last 6 months, it's 2 seasons. So we see a drop in the irrigated water in terms of contamination from both in arsenic and fluoride from I give an example of fluoride over here from 3 to 5 ppm to less than 0 to 5 ppm. Naturally, because we are using rainwater as an input or treated water, and the amount of water to be used here is very less. We have not yet tested for the residues in the food produce, but yes, we plan to do. I mean, we are assuming as of now that since the input irrigated water is low in these contaminants, the output food would also be low. So I'm just presenting here these 3 examples as 3 broad.
If you don't mind, can you finish in 2-3 minutes? Next 2-3
Yeah.
minutes.
And coming to the last slide, yes. So these are 3 examples that I'm presenting from my side in terms of early stage and ideas for looking at solutions which are, I would not say completely nature based, but as close as possible. And 3 more, few more things that we and also others are working. I think nitrate in water especially is an area very less addressed and which is possibly much more amenable to nature based solutions. Definitely in terms of looking at the cause of the problem, but also having natural process to reduce nitrate. We are not working on it. We'd like to know if others are, and to collaborate on it. There are plants which are absorbing high fluoride and arsenic naturally, but the question is of where do you dispose it and what you do about it. But yeah, we plan to do more work on that. And then in areas with just salinity management, having crops, as I mentioned here, but also aquaculture and other means to diversify and adapt to the situation. So just these basic thoughts and broad ideas. Thank you so much. Thank you.
Thanks, Sundar, for completing the presentation well on time, and you covered geogenic contaminants and then QCRA, and you also talked about discharging RO water, RO reject water rather having say high TDS. And you might also be aware of ICS program in which they are developing crops which can be high salt tolerant also. So these are really good experiments. So we'll open the forum for questions. We can take a couple of questions. So if there's any question to Sundar, we can ask Sundar. Please raise your hand. Yeah. Kindly introduce yourself.
I'm Marcela de Souza working in, my question is, see, when you've shown that filter for that slow sand filter, and I assume that the arsenic is slowly being collected in the buckets. What happens to that? How is that treated? How should that be prevented from getting back into the soil?
Yes, Marcel.
Yeah, could you hear?
Yeah.
Okay, over to you.
Specifically in this case, the process in which the entire monovalent ion is produced here and arsenic to arsenite and arsenite gas being produced. The final sludge which is being generated here is very less toxic and amenable to contaminating the environment. Again, but yes, you're right that potentially it is possible to again oxidize back and again to come back into the environment. That is an issue potentially. You're right about it. It is a broader issue potentially.
I would like to add, see,
Yes.
now this hazardous waste disposal notification is out and they're seeking comments. And unfortunately, the only option which is left to arsenic treatment unit is that it should collect this waste and dispose of in this disposal sites. But there are several studies which have been done on, they're known as TCLP, toxic characteristic leaching process, in which it has been established, as Sundar pointed out, we convert this trivalent arsenic to hexavalent arsenic, and that is fairly stable. So it gets bound to the media and it doesn't hardly leach. So that's the benefit of it. But at the same time, we should find out some solution. They're trying to add it to the road construction. There are many processes which are attempted. So is there any other question to Sundar? Okay, if there is no one, there's one more, yeah.
Dr. Iyengar, I've been looking into this arsenic problem to get some pure water from arsenic contaminated bore wells and wells. Ultimately, you are able to, there can be several methods of removing the arsenic. I myself developed one and given it to AquaGuard Greco folks. The problem remains what to do with the arsenic loaded sorbent. This has been problem, I think even IIT, Dr. Pradeep, they put up huge community wells. And after this is entrusted to the village panchayat or something, they will just remove the drum and put it again. So this has been a universal problem. Unless that is worked out as engineered landfill or something has to be worked out, then only this problem can be totally eliminated. Otherwise, it will keep on cropping up. You put it somewhere else, it will crop up in that particular area. So I think the satisfactory solution is yet to be found out, and I think we should probably put our heads together and arrive at a very, very perfect, perfectly engineered.
Thanks a lot. Thank you. Thanks for that suggestion. So thank you, Sundar, for your presentation. Yeah, thanks a lot for being with us.
Moving ahead, our third presentation is by Mr. Sunil Rajavaram and Mr. Lalit Sharma. Mr. Sunil is a senior manager, WASH Technology at Cost, where he has been working for 13 years, managing relationships in India and Afghanistan and coordinating the global HWTS network. With over 30 years of experience in development, he began his career as a technical officer, mobilizing Adivasi farmers in southern Gujarat. For water management projects at Cost, he has been instrumental in expanding partnerships with 10 organizations across 6 Asian countries, including India, and has provided technical support for training in 13 countries across Asia, Africa, and North America. Mr. Lalit, Principal Scientist, Water Research and Trainings at SM Sehgal Foundation. A civil engineer with an MTech from IIT Delhi, he is a co-founder of the Indian chapter of the Household Water Treatment Network. His groundbreaking innovations, including the Jalkal and Matikal water filters, addressing arsenic, iron, and biological contaminations, have been recognized by the Government of India. We welcome you, sir, on the stage.
Thank you very much. We come in 2-in-1 package. When Arsh approached me and said, would you like to make a presentation on biosand filter? I said, when Lalit is there in India, why do you want a presentation from a person who is living in Canada? But anyway, we have long-standing relationship, both with Lalit and Arsh. So here we are. So this, slow sand filter has been one of the best nature-based solutions, and it has been working from last 300 years. But people seems to have forgotten. Sometimes we adopt it, sometimes we don't adopt. But in any case, our founder, when he was working at the University of Calgary, David Barnes, based on the slow sand filter principles, he developed a biosand filter. And just I want to give a little bit of introduction to the biosand filter, because I know here there are PhDs and there are also students. Various kinds of levels are there in the room. Little bit of introduction. Originally biosand filter is designed to remove pathogens and turbidity. But eventually it removes iron and manganese also. But with addition of, which as Sundar explained, addition of iron nails, zero valent iron, it proves to remove arsenic in number of locations, including India and Nepal. And Professor Pawan told me 15 minutes, so I'm skipping some parts of my slide.
You can take 20 minutes.
Yeah. And Cost is involved in promoting biosand filters. These are the 3 popular models of biosand filters. Concrete one, original one. This one, it can be manufactured locally with local material such as cement and gravel. Hydrate, an American company in partnership with DuPont and the American Army, they make and ship these filters on humanitarian reasons for number of destinations. Jalkal, the name which is the Sanskrit name, Hindi name, is modified by Lalit in India. This also has been popular not only in India, China, India, Nepal, and Cambodia. People started implementing these filters. So, like I said, I just one slide. How is it a nature-based solution with mechanical trapping, natural absorption, and because of a biolayer, the name is biosand filter. Because of a biolayer, the predation happens very much, which improves the efficiency of a biosand filter by 30%. And once again, Lalit's ingenuity, he added copper foil at the bottom layer where the water comes out. That also is adding extra disinfection. And as I mentioned, I work for COST. We did not mention the location. We are based in Calgary, Canada, and we travel to different countries and provide training on this particular technology and promote this technology. Mr. David Barnes was founder of our organization. Now he's no longer associated, but one of the approaches he has taken is promote it through training. So literally, we did provide in-person trainings in more than 65 countries, and we collect information from the trainees, participants. What do you do after the training? And in last 20 years, around this data was collected in 2023. Collected in 2023. 1.7 million biosand filters have been made and placed around the world. This is how we've taken up the scaling up approach for biosand filters. Anyway, so why biosand filters have become popular? Number one is the removal of iron. In Bihar and in areas of Nepal, more than 50,000 filters per year are placed. The red water with iron goes into the filter, it comes out crystal clear. There is lots of appreciation of this by the communities, and people have adopted it. And this is also, I would say, no to low maintenance. But one of the challenges of, even though we said 1.7 million filters have been placed with efforts from COST and our training partners around the world, lack of funding is one of the key challenges we face for the implementers. Rotary clubs have played a significant role in addition to the different bilateral programs of different governments. And the second biggest challenge, I have not listed it, but it is lack of lack of excitement, lack of encouragement, lack of support from the policymakers and various people who are in the influential roles. I think with this, I hand over the floor to Lalit. Lalit is very much a technical expert. He'll go a little bit more into the details of the technical aspects.
Thank you. So this filter was originally designed for turbidity and microbial load, and in different parts of the world it has been studied, and we found that the microbial load removal ranged from 1.73 to 3 LRV, and this variation is majorly because of sand quality available in different parts. Arsenic, how arsenic is removed? Basically, arsenic 3 is converted into arsenic 5 through oxidation, which is taking place naturally in this filter. And then at the same time, the zero valent iron we put in the filter, because of intermittent interaction with water and air, it gets converted into hydrous oxide of iron, and that absorbs the arsenic 5 very easily. there was a question about how to dispose the sludge accumulated. So we have conducted this PCLP study for this sludge, and we found that it is safe to dump with municipal waste. It was done at IIT Kanpur. We also worked with IIT Kanpur for chromium removal, and with just selective coagulant, addition of selective coagulant, we were able to remove the chromium in Kanpur itself. Even then, because it was very successfully doing microbial arsenic iron, even then we found under a DST supported project where DST is subsidized for 3,000 filters. Only 10% of households in a village were able to or were attracted to put in these filters. Whereas almost 70%, only 70% cost was recovered from the household, 30% was subsidized by DST. So we found that even 70% cost was not affordable to them. So then we tried to go with more affordable filter, and this is Multicul, which is made of clay and combustible material. Of course, we impregnate silver into it. And that is also originally designed for pathogens and turbidity. And it also worked on manganese and iron. Basically, when the clay body, which contains combustible material, when fired, it produces some micro cavities connected with microchannels, network of microchannels. And when we impregnate silver, that silver coat the microchannels and cavities, and that silver coating improves its microbial removal capacity and reduces the biofilm formation in the storage container, because it releases a small amount of silver and within safe limits, very much below the safe limits of this. And it also protects recontamination of stored water. We have also tried the feasibility of integration of zero-valent iron technology in different conditions, and we found it is possible. And we were able to remove up to 1,650 ppb arsenic through this in Buxar, Bihar. This filter has been studied by Terry School of Advanced Sciences for iron, manganese, and microbial contamination, and they found effectively working for that. Here also, the major enabler for adoption was, first of all, highly affordable. And once it is locally produced, so it is available locally. And the approach for scaling up this filter we adopted is we train the local porters how to make it, and then they start producing it. So far, Bihar, Uttar Pradesh, Haryana, Andhra, Telangana, and Maharashtra units have come up, and there are few more in process. And we are providing just training the porters. Of course, some NGO is involved in the process, local implementing NGO. As far as the barriers for adoption are concerned, certainly sometimes the quality of produce is not consistent. It may be because of the locally available clay or maybe human behavior. Then flow rate is slow. So instant treatment is not possible. And of course, supply chain and handling issues are also there. So in this case, we don't know all over the world how many filters has been adopted so far, but there are 2 case studies where 7 lakh in Guatemala and 4 lakh in Cambodia is recorded, documented. In India, it has been promoted. Dr. Anand from IIT Jodhpur and Sagal Foundation, we are also doing. Would you like to?
Like I mentioned before, because of the clear change in color and people like taste coming through the sand, the water quality is accepted by the households. And in one particular project we study, the households have saved 850 rupees per month. That is both that includes money saved in purchasing the bottled water and the medical expenses. This one would cost, if it is a biosand filter, around 5,000 rupees. And if it is a ceramic pot filter, it is 1,000 rupees. That is the cost. And then reduction in diarrhea. This is predominantly designed to remove the microbiological pathogens. In this case, ceramic filters and biosand filters are in this range 61 and 53%. And actually, I forgot to keep another line which talks about piped water supply. In the case of piped water supply, also it is in the same range, 55 or so. So reduction of diarrhea is very effective with this kind of filters. So certainly, it's providing better health, saved expenses. The kids can go to school, the households can go for the work. It is a viable solution, whether a biosand filter or ceramic pot filter. Hope more people will adopt it. As an organization, both COST and Sagal Foundation, we are willing to provide pro bono training and technical support. And I also hope that policymakers also will support. So before Dr. Pawan warned us, we ended our presentation.
Oh,
Thank you.
thanks a lot. In fact, I given 20 minutes, you could finish it off in 15 minutes. So
Yeah.
great. So we can definitely take a couple of questions.
Yeah, more
Very,
questions.
very interesting
Yeah.
presentation. Yeah.
Can you expand on biosand a little more?
Yes, sir. Dr. Lalit, a doctorate in bioscience. He will explain.
But what it claims, because the sand particle is a biomaterial, whether it's a char or how the economics works out.
So basically, it's a sand column. And then the sand is prepared like 0.6 to 0.7 millimeter of particle size. There is a designed depth of the column. When water having contaminants and turbidity goes into the sand column, the top layer of the sand act as a sieve or a filter. So the larger size of pathogen and the suspended particles get trapped onto it. So the microbes which has been trapped on the top of column, they start colonizing on the surface of the sand particle. And in this process, we call it adsorption. So one is mechanical trapping, second is adsorption. These microbes interact each other with newcomers and start redirecting. So that way, predation also takes place on the top of layer, and this layer we call it biolayer. That is why the name is biosand. If any microbe goes below, now if you go below, there is no oxygen, no light, so living conditions are not conducive. So that is why their natural death or anaerobic conditions cause that death of those microbes. Even then, if any goes down, So we have provided the last safety guard, copper. Copper has a germicidal properties. So once it get in contact with the copper, that breaks its surface. And so that way, it is able to remove up to 3 log reduction.
Yeah, thanks a lot. Is there any
How
other
the
question?
economics works out, sir?
Pardon?
How the economics works out per square
Okay.
meter of biosand or something like that?
This Jalkalp, what is produced in India, we cost around 3,500 to 4,000 rupees each filter, including all filter media and all. And this filter media, once you install it, it is for lifetime. You need not to do anything. Sometime when the silt particles coming with water gets accumulated and it will clog the pores, and because of that, the filtration rate will go down. At that time, you have to remove that silt accumulated. So for that, you just put water, swirl it, and scoop it out. And just after 2 or maximum 3 repetition, it gain the same flow rate as it was earlier. So there is no maintenance cost.
You have put one.
Sir, I'm sorry, I had to stop because we are running out of time. But yeah, we can discuss offline also. Yeah, thanks a lot and great presentations. So, yeah, and I would like to thank all our technicals who could finish their presentation well within the time. I'm really sorry because we have to manage time. That's why we are unable to take up questions, but I'm sure that we'll get time during tea and we can informally discuss with them. So over to you.
Thank you everyone for the engaging sessions. We shall now start with the panel discussion on this subject. May I invite all the panelists on the stage as I call out their names with their brief introductions. I would first like to invite our first panelist, Dr. Kunal Kanti Majumdar, a distinguished public health expert with over 3 decades of experience in community medicine, environmental health, and epidemiology. Currently a professor and medical superintendent at KPC Medical College, Kolkata. He has been instrumental in research and policy implementation on arsenic and fluoride mitigation, environmental epidemiology, and sanitation management. As a consultant to UNICEF and WHO, he has contributed significantly to water safety and health capacity building. A prolific researcher with 83 publications, he continues to shape public health policies, medical education in India. Sir, it's a pleasure to have you amongst us. The next panelist would be Shri Ejaz Hussain, a seasoned civil engineer with over 3 decades of experience in infrastructure development. As chief engineer at Karnataka Rural Water Supply and Sanitation Department, he has been instrumental in ensuring safe and sustainable drinking water access across rural Karnataka. A leader in implementing Jal Jeevan Mission and World Bank funded projects, his expertise spans multi-village water supply sanitation and rural engineering works. We look forward to an engaging discussion with you, sir. As our next panelist, we are honored to introduce Dr. R. Srinivasan, a distinguished geologist whose work has significantly contributed to understanding Precambrian crustal evolution and metallogenesis in India. His research has uncovered evidence of Archean life processes and glaciation, and he continues to address groundwater contamination challenges in eastern Karnataka. A fellow of multiple esteemed science academies, he has been recognized with Geological Society of India Gold Medal for the lifetime contribution to Precambrian geology. Great to have you on this panel, sir.
Yeah, thanks a lot. We have very, very distinguished panelists among ourselves.
We have a panelist online who is Mr. Asad Umar, Director WASH at Aga Khan Foundation. With 24 years of experience in water sanitation, hygiene, and water resource management, he has collaborated with global organizations such as World Bank, UNICEF, and WHO, contributing to flagship programs like Jal Jeevan Mission and Swachh Bharat Mission. A PhD in hydrogeology, he has authored 20 publications in water security and sanitation. As an expert in groundwater governance and source sustainability, He continues to play a key role in shaping India's rural wash initiatives. Looking forward to a very informative discussion.
Thanks a lot. Yeah. So we are very distinguished panelists among us, and fortunately we have a doctor, physician, and ultimately water quality leads to health repercussions. And we have a doctor, we have practitioner with us who heads rural water supply department in Karnataka. We are academician also, and we have panelists from NGO. So we have a great combination. Unfortunately, what we don't have with us is time. We'll try to wind it up, as organizer told me, by 3:45. Is it okay? Can we go up to 4? Oh, great, we can go up to 4 o'clock. So what I request to my panelists that I'll start a conversation. I pose a question to you, each one of you, and I request you to kindly restrict yourself to 3 to 4 minutes to respond to those specific questions. In case if you have to share your experience related to that question, it's fine. But if you want to speak something different, then we'll come back to you again. So with that, now I'll start my question with Dr. Kunal Kanti Majumdar. And he's been working in West Bengal, particularly in arsenic and fluorosis, arsenicosis and fluorosis affected areas. So Dr. Majumdar, with your rich professional experience, what do you feel is the extent of public health challenges which is being faced by communities due to pathogenic and geogenic contamination in drinking water? What are the major prevailing challenges? It really reminds me of a study which Professor Guy Howard, while working in UNICEF, Bangladesh, had worked, and he had worked in a core arsenic affected areas. And through his study, he proved that despite exposure to arsenic, the pathogenic contaminants had more morbidity and mortality. There are several studies which actually reveal that pathogenic contaminants are also equally important. Somehow we give more importance to geogenic. It doesn't mean that we shouldn't give geogenic contaminants that much of importance. But how do you feel that we should balance between two? How should we prioritize? Should we consider both geogenic and pathogenic contaminants as important contaminants? And how do, based on your experience, narrate the preventive and say curative measures we should undertake? Over to you.
Thank you, sir. It's a huge topic, very difficult, wind up in 2 to 3 minutes, maybe 5 minutes. But as a public health professional, I'm extremely grateful to the organizers, as well as Mr. Dipankar Shah, who has invited me. As health is always a neglected topic, including public health. But I'm extremely privileged to be here in front of some learned audience. So main public health problem that we are facing, drinking water, that is contamination. So drinking water said to be safe when it is free from microbiological as well as chemical contaminants, easy to taste, does not have any odor, smell, palatable. And mainly we are concerned with two. One is microbiological contaminants, mainly some bacteria, viruses, parasites and helminths, which can cause diarrhea, dysentery, starting from cholera, polio, hepatitis A, and large number of other helminthic diseases. But these organisms mainly pollute our water through our fecal contamination. So installing sanitary latrines as well as all, and we have already discussed separate spheres for storm water as well as sewage, that can prevent a lot from contamination of the pathogenic agents. But for arsenic and fluoride, these usually occur in the groundwater. Mainly it enters our body through groundwater. And when we have switched in the developing countries, when we have switched, most of the villagers, as most of the use tube well water as drinking and cooking purpose, then we are more and more facing these chemical toxins like arsenic, fluoride, etc. And arsenic, you know, it's a carcinogen. That is why it is very important. And in our state, at least 8 districts and 83 blocks have been affected. More than 6 million people are exposed. More than 1 lakh of them are suffering from severe disease, and some of them are suffering from cancer also. Besides cancer, usually it starts with some clinical manifestations, skin manifestations like pigmentation and keratosis, but it affects all the systems of the body, starting from respiratory system, gastrointestinal system, and also the nervous system. Same as fluoride. So it is a crippling disease. It has affected 7 blocks, 7 districts and 43 blocks in West Bengal. And the main source of entry of arsenic and fluoride is groundwater. It is used for drinking and cooking purpose. But the most important problem that we are facing now, that as we are using groundwater for irrigation purposes, the arsenic is also entering through our food chain. Even the studies have conducted in West Bengal, we have found high levels of arsenic in rice as well as in vegetables, because we are predominantly based on rice as a staple food. So a good amount of arsenic enters in our body through rice, but arsenic which is entering our body through food items, especially seafood and other food items, their bioavailability is less. It is less harmful than arsenic which is entering through water. Similarly, fluoride also enters through that drinking water or groundwater which are used for drinking and cooking. Plus, besides, fluoride is also present in some food items like black salt or in supari or in tea, which is black tea without milk, because milk bound calcium binds fluoride. In fluoride endemic areas, those who are there is high risk of getting fluorosis if the person takes black tea without milk and the water contains high level of fluoride, and red salt is also there. So these food materials also pose a great problem for arsenicosis and fluorosis. And we are facing challenges because fluoride is also a crippling disease. It starts with dental fluorosis, causing disfigurement of the teeth of the children, especially 6 to 11 years children, and causing a cosmetic problem. And in the near future, if it is untreated, they may lose their teeth. Mainly the temporal teeth is mainly affected. But in adults also, it affects the skeletal fluorosis that affected the deformity of the bones, leading to restriction and rigidity of the movement and skeletal deformity. And there is another part is non-skeletal fluorosis, where other systemic manifestations, just like arsenicosis, that is anemia, as well as there is a diabetes insipidus, there is some GI problem, gastrointestinal problem like dyspepsia, and there are some infertility cases. Anemia in case of pregnant woman can lead to low birth weight, stillbirth. So this is a spectrum of disease, an important public health problem that is caused by groundwater. As Sundaran has said, that we have solutions. Nature-based solutions is not so much popular in our state. Mainly, as in both the cases, water is the main problem. Arsenicosis, there is no specific treatment. So stoppage of drinking water for cooking and drinking containing high level of arsenic is the only intervention. So surface water based project like selecting and identifying some pond, along with that attached with slow sand filter has been tried in some of the in 1 or 2 districts in West Bengal. It is supported by All India Institute of Hygiene and Public Health, in one in North Chobbish Parganas, and in Assam, Saki Waters in Jorhat, Titawar, we have conducted some surface water based flow projects. And also in case of fluoride, in 1 or more schools, rainwater harvesting has been piloted, and it was sponsored by UNICEF. And but these are some stray events. It has not been so much popularized because we have already discussed that these type of projects needs community participation, involvement, community ownership, as well as political will. Lack of political will, that is very important. Very indicates some advocacy with the government regarding policy. But last, I will finish by saying that these sort of our problem, arsenicosis or fluorosis, this mitigation needs a joint effort. Not only the public health specialists or doctors or engineers can do, it needs a consortium of doctors, geologists, public health engineers, environmental scientists. We should come together in a common platform to solve this problem. Thank you.
Yeah, thanks a lot for elaborating very, very complex correlation between geogenic contaminants and health. And I'm sure because we are restricting your time so that we can get questions from audience also. I'm sure that there may be many questions from them. So now I'll move to Shri Azaz Hussain Saab. You've been leading this RDWS department, and I'm sure that there's major emphasis now on water quality monitoring. So please share your experience in setting up these laboratories, distributing field kits, fixing online monitoring system and you're training community-based organizations and community. So what's your experience in the last 6 years, 7 years since when we have started giving more emphasis to water quality, and how are you using water quality data in provision of safe water to the community?
Thank you, Paul. Thanks, CTD, the organizers here for allowing behalf of the government to be part of discussion. Really delighted to be the distinguished audience. First of all, let me brief about my department, as Pawan is asking me to brief about the laboratory system that we have in place. Since the drinking water is the most essential part, and since I am involved with the rural sector, that also has much more importance, I can say, because it was the neglected area with respect to this water supply. And since I have been seeing the presentations which I could see, I have seen a lot of research going on in the quality of water. Thanks to Jal Jeevan Mission, which has allowed the water to be brought to the doorstep of the rural household. So each rural household is expected to get the clean drinking water on a regular basis. That is the mandate that the Jal Jeevan Mission has given to the department. Thanks to our state government also, which is supporting along with the government of India in getting the water to the doorstep. And while giving water to the doorstep, the quality is of utmost importance, and same importance is given to the quality of water. For that, let me brief from the government side, government of Karnataka, that we have 80 laboratories enabled accredited established across the state. Each village is mapped to a laboratory, so that no village is left out, no sample is left out without getting tested. We have mandated each laboratory to test 3,000 samples. So that way, with respect to chemical, I am telling, 240,000 samples get tested every year. And there is a robust system in online monitored by Government of India also, wherein we enter all our results. And in addition to these results that we do at the laboratories, we have field test kits provided at each village. And we train the village level, the PDO there, the Panchayat Development Officer, the village water sanitation committee members, so that they themselves would be able to test the water there. On hand, it is what I can say, a rapid testing result that we can get. Based on any contamination that we come across when we use those field test kits, we immediately take the sample to the laboratory and get it tested again to confirm any contamination that is found in the sample. In addition to this, we have got this microbiological testing also. Of course, I admit that we have not established that robust system of microbiological testing laboratories, but we have empaneled private enabled accredited laboratories so that we can make use of the testing done there at those laboratories to get the results. And I'm also happy to say that we took some campaign pre-monsoon and post-monsoon last year using field test kits, wherein we could test 5 lakh samples, and we will be able to get the results on hand. And based on the contamination reports, remedial actions were taken. And we had the alternative sources identified when any source is found contaminated, and we could ensure that the water sample that is getting distributed to the villagers is of the safe standard. I understand the difficulties that which we have been facing in the department to get the water samples tested, but still one important thing which I would like to mention here is that we have also developed an application. We call it as Jeeva Jala, which was recently launched. And in that Jeeva Jala, we select the samples using that app only. Even in the sample collectors, they get geofenced there where they collect the sample, either at the village household or at the source point or at the village over a time. So that gets geofenced, and that sample gets automatically numbered and it goes to laboratory. All monitoring will be done till the dissemination of results. So that way, the state is doing a robust system of quality control. Still, we feel that there are some outbreak incidents. So in that case, it becomes a challenge for us to control the contamination. That action is also being taken. So that way, the state government is doing.
Yeah, thanks a lot. Thanks a lot for highlighting government's efforts. And as you rightly pointed out that you have to now upload the data on water quality to say website of Department of Drinking Water and Sanitation, and they usually check that how are we taking a corrective action. Thanks a lot for that feedback. So yeah, Asad bhai, we'll come back to you later. So we have Professor R. Srinivasan, and you heard say in first session we talked about say MAR, manage aquifer recharge, aquifer recharge, and Professor Ilango also talked about fluoride dilution due to say recharge. And you have been working here in Karnataka for a long period. So what are the measures you feel from this particular perspective we can further say improve? And what do you feel that some futuristic actions we can take so that these activities or these initiatives which we already taken can be further strengthened?
Would like to thank CGD.
You have to come.
The Indian Institute of Science, the Vischer Center, we have been focusing on emerging contaminants. We are all aware of the amount of effort been going on, addressing the problems connected with fluoride arsenic. But during the last 4 or 5 years, the uranium contamination has come to fore, Karnataka. In fact, actually, the number of sites on which we have worked, something like sites, but nearly 65% of the sites have uranium, even more than. And of late, we have been seeing also microplastic contamination coming in. So these are new challenges that are coming up, and addressing the problem of removing uranium and also how to dispose that which is removed. Challenge. In fact, Karnataka government very, very encouraging to start with. Moment we brought this to the attention of the Karnataka government, they immediately took the steps to see that all those villages where this has been found, they installed RO machine to give clean water. But where the uranium content is much higher than say 1,000 liter, what is permissible is micrograms per liter. So even after RO treatment, when it comes down, it doesn't go below 6. So therefore, there are many places where these are in thousands of micrograms. So we need to address this. The problem.
You have to hold the mic.
Therefore, we need to really develop methods to address this problem, removing uranium, and we are carrying out certain tests which are still not final. I would like to mention that. And these very same samples in which we uranium, in many have started seeing the microplastics as well. This is also a new and emerging contaminant. And it has been found these microplastics can have very serious health effects, especially in terms of neurological disease. So dementia is one of the important issues which has come up in the older age group of this country. So, and this can become a pretty serious issue. Do not take. As of today, I have no solution for the microplastics removal, especially we only know of filtration. things like that, but those things do not successfully remove the micro and nanoplastic. And addressing the problem of uranium also is a very serious one. I think this is the area of research which is currently going on. A lot more work.
Yeah, I think, thanks, Professor Srinivasan. You highlighted very important points of both microplastic as well as uranium. Yeah, Professor Pradeep at IIT Madras has developed some adsorbent which specifically can target
The
uranium.
surprising thing is to expect microplastics getting into the aquifers in sedimentary terrain or in alluvium was quite understandable. But getting the microplastics in hard rock aquifers as well is something which has taken us by surprise.
Yeah, that's really great, sir. We'll come back to you through audience. Now we have a question to our last panelist, Mr. Asad Umar. And Mr. Asad, a question for you, that you've been working both in urban and rural area. Both have, say, different settings. Yeah, they have different challenges. So do you want to differentiate these water-related challenges in urban and rural context? Or do you feel that the challenges are the same? We have to come out with different solutions. So what's your take on water-related issues in urban and rural settings?
Thank you so much. Thank you so much, Pawanji. And I would also like to express sincere gratitude to CDD for giving this opportunity. As far as challenges in rural and urban settings are concerned, in many cases, as we are dealing with same catchment areas, then certain challenges are similar. But definitely there are issues, operational issues, the capacity-related challenges. Those are significantly different both in rural as well as in urban settings. It also depends on the kind, the overall challenges, the kind of infrastructure that is being put in place, the population density, and the environmental conditions. Now, Pawanji, if you just look at the kind of issues that we are facing as a country, as far as these challenges are concerned, we know we have unique issues in hilly terrain. As far as water quality is concerned, we have our own challenges, both in rural and urban settings. We have our own challenges in highly densely populated Gangetic Plain. We have our own issues and challenges in coastal regions. Now, if you just look at some of the major geogenic contaminants, as we all know, I mean, in this room, all the researchers and scientists and practitioners are sitting there. But if you just look at arsenic, it is almost impacting more than 10 states, fluoride, 20 states, the salinity issues. We have huge coastal lines, so a lot of states are impacted by salinity. Iron is another key challenge. Almost every state is having this particular issue. Then, of course, nitrate is emerging and heavy metals, as we all know, because of industrialization and all. Now, coming back to the rural, there are some unique challenges in rural settings. As I was just listening to some of the speakers, some of them has also actually linked water availability with the quality concern. So what we have seen, especially in rural setting, that especially in summer season, though we have actually initiated, as the other speaker has mentioned, one of the largest program, Jal Jeevan Mission. And Jal Jeevan Mission is actually aiming to ensure a sort of universal access across country in terms of safe and sustainable access of drinking water. But in case of many states which are facing, especially the water scarcity situation, people are tend to going back to the unsafe water sources. That is one part. Second is, of course, in many regions we have also seen, especially in Gangetic Plain, is a kind of surprising thing as a practitioners. What we have observed that still people are actually relying more on their local water sources rather than switching over to, perhaps it would take certain time switching over to the source or the water that is being provided by water supply systems. So it will take its own time to actually ensure that. Then there are certain other issues and challenges if you just especially in rural setting. So those challenges are basically around contamination due to agriculture, poor sanitation and waste disposal. Though we have sort of under SBM phase 2, there are dedicated provisions for addressing issues around grey water contaminations, fecal sludge management, etc. But still, this is emerging as a key concern. Now, coming back to another issue of urban challenges, then I hope all of us would agree that in many cases, aging infrastructure is something that is causing a lot of concerns, especially in terms of leakage of untreated sewage system, then industrial pollution, stormwater runoff, sewage outflow, all are leading to either contamination of river surface water bodies or river water system. Then as Professor Srinivasan has mentioned, that micro plastic pollutants are emerging as a sort of key challenge. So these are certain issues and challenges that we are facing. And I think by and large, if you just look at the overall challenges that we are having in terms of overall access, in terms of the water quality related issues. So of course, there are some unique challenges to urban and rural settings, but what I feel that it is more to do a sort of particular geographies, but the geology part that is much more responsible as far as the water quality related issues are concerned.
Yeah, thanks a lot. You brought out very, very important and distinguishable challenges between urban and rural water supply, and particularly in the context of water quality. So we can open this session to audience. I'm sure that we will be having some questions to our audience, and I request you to raise your hand, introduce yourself, and please also mention to whom you want to address your question.
Hello, this is Madhuri. This question is to Mr. Aizaz, RDPR. You had said that you do check for water quality. Do you check? I mean, I know nitrates and arsenic and fluoride has been acknowledged, but the presence of pesticides even in rural areas is a concern. Is this data, first of all, available in the public domain? Second is, do you look for these which are prescribed as per the BIS 10,500 drinking water standards? Do you, actually analyze for pesticides at least once a year?
Specifically, no, you can say, but as per BIS 10500, the whatever parameters are there, based on that, we have the results test them twice, and the results are available online. We have this JJM WKMS website where the results are uploaded as and when we get the test results.
So just continuation of this question. Yes, on the website it is available. Is there any thinking to disseminate this information locally to the user?
Yeah, from the state government of Karnataka, I'm very much happy to say that we have this application open to public, and not only that, those who are using the applications are able to get the results online. That app is given wide publicity also. In addition, what we are doing is at the Gram Panchayat level, we are displaying the results on their notice board. That is one mandate that we have done in our state. We are getting the results displayed.
Dr. Pawan Chanakya. This is to Professor Dr. Srinivasan. I also had a small stint with looking at radioisotopes and working with it. And also we had a very strong department of earth sciences in IISc. And we have not seen uranium in the water or in the groundwater. Now it's suddenly emerged. I request Dr. Srinivasan to explain why this problem seems to have come all of a sudden, and it has no historical evidence of this. So what could be the phenomena that makes it happen? Thank you.
say around 2017-18, I think, for the first time in India, the Duke University from United States first published an important paper in which they brought out the occurrence of uranium contamination in areas in Punjab, Haryana, Gujarat, and those places. And our own understanding of the geology of those regions showed that the uranium could have been derived either by phosphatic fertilizers, and phosphatic fertilizers were being extensively, rock phosphate was being quite a bit used in those areas as for fertilization, soils. But ultimately it turned out that the groundwater table also was going down. And as it was going down, more and more of uranium came to be recognized. And it was found that the Sivalik rocks, which underlie the recent alluvium also, or which is enriched in uranium, could contribute the water being contaminated by uranium. Now, in Karnataka, coming back to talking, Karnataka state has an eastern part of Karnataka, which is composed of granitic and granodioritic gneisses, which are more rich in potassium, uranium, thorium, these large ion lithophyll in the granitic rocks, as compared to Eastern Karnataka, where the rock formations are more rich in sodium-rich granitoids. Now, this large ion lithophile-rich granitic rocks being abundant attracted my. We had done the gamma-rated spectrometric surveys across the state earlier for heat flow studies. That is how the data was. Then he thought that I don't look at see whether there could be contamination from urine. So fortunately for me, one of my colleagues, Achyut Pandit, he was carrying out exploration for uranium in the northern part of Karnataka. And he routinely used radon surveys for in-ground water for tracing uranium isotones. Our uranium deposit somewhere near Gulbarga, that is Gulbarga district near Bogi. So this is the background. And then I said, if where there is a deposit, uranium contamination, but since the general abundance level of uranium itself is high in the rock, could be happening. Because there is more and more intensive exploitation in the eastern part of Karnataka, where farmers totally rely for agriculture on groundwater in the water table going. It is also a comparatively dry area compared to the western Karnataka. Therefore, we just out of curiosity started looking at the groundwater in this particular region. And to our surprise, indeed, the uranium was high in these rocks. And then we tried to understand the reason why it could be coming into the groundwater. All this area is subject to intense oxidative weathering. Uranium in its reduced state is found as the uranium mineral, but in oxidized U6 state, it can go into solution into the water. So both these explain as why it is coming in groundwater in this particular area.
Why so recently?
Pardon?
Why so recently? Because it's
Probably we didn't look for it.
Yeah, I think we might have not monitored.
We didn't look for it.
Park has looked for it.
One thing, and second thing is, since uranium determination also was something not routine in our geochemical analysis, we were missing this particular aspect. And even when we have determined uranium way, we have to go and determine it in a laboratory accredited by nuclear
Yes, yes.
atomic
Thanks, I think
energy.
your question, your response was very elaborate. We'll discuss. I think we can take last couple of questions before we close. Yeah.
It's not a question, supplementing to Dr. Srinivasan's explanation on uranium in Karnataka. See, actually, you use the word how suddenly uranium has come into picture. There is no sudden. Actually, we thought that we were doing the exploration for uranium in Karnataka almost for the last 50 years. One such basic unit is the Babagudan conglomerate was having uranium that is found in Western Karnataka, particularly in Chikmagalur and near Mangalore, as well as in some parts of North Karnataka near Kaiga and also Arbai. So then slowly we thought that we will also do the uranium surveys on the Eastern Karnataka. We found that uranium content was very high in the Eastern Karnataka regions, and the regional aeroradiometric surveys, which started only after 1960s and 1970s. So we found that high uranium thorium ratios. So when I was doing some work in Bhima Basin, as he told that I could able to locate a fairly big deposit of uranium in Gulbarga, and that is near Gogi. So when all these days we were not knowing the health impact or whether uranium is being ingested in water while drinking for the general public. So slowly it developed, and you see even Central Government Water Board and many other agencies also, they have not included uranium in the normal list. That is why it looks sudden. Otherwise, it is not a sudden thing.
So thanks a lot. Thank you very much. I think your response was very elaborate. And sir, I think because we are at 4 and we have to close unless there is a last burning question by anyone. Okay, thanks a lot. And because we have Dr. Majumdar, so there will be last chance to me, and I'll be asking a question to him and request you to summarize in 2-3 minutes, sir. See, there's a study done by Jennifer Wolf of WHO, and she has come out with findings that we are implementing pipe water supply, and it will reduce the waterborne diseases. So the death by waterborne by 4.5 lakhs, and then there will be daily reduction by a few millions. So what do you feel that we should do for the improve reduction in waterborne diseases? Do you agree that there will be considerable improvement as far as reduction in waterborne diseases due to implementation of pipe water supply schemes, particularly in rural area?
I think Jal Jeevan Mission is a very encouraging thing. If you can distribute pipe water supply after proper treatment, disinfection, that can reduce very increased number of waterborne diseases as well as morbidity as well as death. And only because most of the waterborne diseases related to our personal hygiene, sanitation, as well as access to safe water. So if accessibility is adequate, safe water is there in each and every house, then and the people use that water, then obviously the burden of our waterborne diseases will decrease. Even the simple, what I already said, the simple installation of is sanitary latrine And what we did, that stoppage of open field defecation, installation of sanitary latrine, which does not contaminate groundwater and surface water, which are the criteria of a sanitary latrine, that can reduce the burden of waterborne diseases. So access to safe water, awareness, proper hygiene, sanitation, all these things will definitely add to decrease in our disease burden. But the geological things, either arsenic or fluoride, those mitigations we have already discussed. Those areas where arsenic level is high, how to remove the arsenic content by means of surface water projects or by means of drawing water from deep tubewell and supplying it through pipeline or some arsenic removal plants, or in no safe source by using filters, which we have already discussed. So we can subsist and we can decrease the waterborne diseases to a great extent.
Yeah, thanks a lot. And with this, we close, and I would like to thank all the panelists, Dr. Kunal Kanti Mazumdar, Azaz Hussain Saab, Professor Srinivasan, and Mr. Asad. So thanks a lot, and thanks a lot, audience, for your engagement.
Thank you to all the panelists for their insightful discussions. To honor the esteemed panelists, speakers, and the moderator for their time, wisdom, and invaluable contribution, we would now like to present a token of appreciation, requesting my colleague Andrews to kindly present the memento. I request all the speakers for the session to come on the stage. Dr. Ilango Lakshman, Mr. Sunil, and Mr. Lalit. Okay. He said. Okay. Can we have a big round of applause for the whole session? I request all the speakers, panelists, and the moderator to stay back on the stage for photograph. Thank you, everyone. We now take a coffee break, and we will reconvene in next 10 minutes for our next and final session on using nature-based solutions to manage water bodies and wetlands to enhance aquatic ecosystem.
newer Himalayas. They are sediments content because it is also in Pakistan. Ordinarily we detected, but it was there. Maybe because of the excessive withdrawal of water and other things was not evident. But in past we can.
Arsenic you are talking about.
Yeah. Yes, same thing. Leaky there.
Secondly, the definition calculated flow changed. We क्या होना है कि फुटहिल्स की तरफ तो वाटर लेवल स्टैटिक है, लेकिन नीचे आके प्लेन्स में ज्यादा डाउन होता जा रहा है, तो डायनेमिक्स yes, yes.
Because of excessive sinking was near the bay. Bangladesh and India was we are the highest level of activity. More into play now. Now we are constantly identifying more and more. But after 10 years of law, 1983, the last case was identified in Canada. It was there for
actually, I was eager to instrument.
आपका मोबाइल फोन
अभी यहाँ मेरा काम ही नहीं कर रहा है।
सब मैं अभी निकल रहा हूँ, but you can anytime call me right away. अच्छा यूज करेगा it should not disturb the battery. Secondly, wherein जब किसी एक surface पे या interface पे there is a drastic change in ionic concentration, then this surface itself becomes a barrier.
Surface tension
सरफेस टेंशन थोड़ा उसी तरह का तो वो अपने आप में एक बैरियर बन जाता है जिसकी वजह से डिसोल्यूशन या डिफ्यूजन जो है वो रेजिस्ट पानी है वो वॉइड्स के बीच में तो उसकी वजह से जो ब्राउनियन मोशन से डिफ्यूजन की पॉसिबिलिटी है वो रिड्यूस लिमिटेड। सो मेरा अपना एक्सपीरियंस ये है कि जितना पानी हम उसमें रिचार्ज करते हैं 85 to 90%
वो हमको स्लो सेट फिल्टर में जाना चाहिए क्योंकि तभी उसका वो क्लियर होगा तभी सेंटर तो वो इलेक्ट्रॉन चला जाएगा
क्ले में तो नहीं जाएगा
क्ले में नहीं जाएगा
और
सेंटर तो चला जाएगा
basically we are recharging the aquifer where water is present.
Yes.
So if we can draw water from there, it means there is something. That is simple.
Yeah, simple.
मैं actually लोगों को बात करने के लिए बड़ा
नहीं बस मैं वाटर सेल का उसके 52 साल से 70 और गवर्नमेंट की बात में था
कभी
आपने लैब में भी किया होगा ना इसका
एक्चुअली मैंने लैब में नहीं किया था मैंने तो फील्ड में ही किया था क्योंकि ये करीब 6-7 साल से लेकिन इसके ऊपर IIT और NIH ने बाद में तो NIH ने इसके ऊपर एक वो भी एक पब्लिकेशन भी है और
अभी डॉक्टर सिंगल है
वो तो चला ही गया उसके बाद तो
बेसिक एजुकेशन
We are about to begin session, requesting everybody to please settle down. Let us now delve into the final session, using nature-based solutions to manage water bodies and wetlands. Wetlands are nature's kidney, crucial for biodiversity and water purification. This session will explore successful restoration models and governance strategies. To moderate this session, it's our pleasure to introduce Mr. P.G. Ganapathy, a seasoned infrastructure and sustainability professional with 25 years of experience across water and sanitation, urban infrastructure and sustainability. Currently a senior advisor at CDD India and a consultant with Wipro Foundation, he has held leadership roles in organizations like Black & Beach, Mahindra Group and Feedback Ventures. Pleased to have you moderate the session, sir.
Good evening to all of you. We have I've been given a challenging task. This is the last session of the day and we are running late. So we have probably, it was meant to be a 2-hour session, but we only have maybe about 1 hour, 20 minutes or so. So I'm going to be little, I'm sort of asking my panelists and speakers to excuse me upfront because I'm going to ask all of them to rush things a bit. But we'll still have a good session in terms of covering all the key issues and so on. We'll start with the presentations, right? And you can invite Venkatesh Datta.
To start the session, we are delighted to introduce Professor Venkatesh Datta, a leading expert in sustainable water resource management and river restoration. His work focuses on rejuvenating the Gomti, Ghagra and Rapti basins through nature-based approaches. A Fulbright Nehru Scholar and British Chevening Fellow, he has played a key role in shaping Uttar Pradesh's water policies and has served as an expert member in multiple government committees. Sir, the stage is yours.
Thank you so much, CDD, for inviting me and getting me here. It's indeed a great pleasure. I like the work you do for nature. And we are all here to restore the fabrics of the nature which got damaged, obstructed, fragmented, and trying our own bits in bits and pieces. But as was pointed in the previous session that by Professor Bavel, that nature is a whole, it's not in bits and pieces, and we have to have an integrated approach, holistic approach. So we get the big picture. We call it the eagle eye view, and the toad eye view is the grounded perspective, like a toad who makes a building block one by one. So this is a presentation on the work that we do for rejuvenation of smaller rivers and wetlands and ponds in various parts of country, particularly in the Ganga Basin. I've been working for the last 20 years on some of the less known rivers of the Ganga Basin, which are not even known by the public, not even recorded properly by the revenue records, and they are forgotten and they are not so important. But as I work on these systems, I get really surprised that to know and to let you know that nature is the best medicine. And there is a great ability of nature to resurrect, to rebounce to normal, to a state which is like not very disturbed. If you just give nature some breathing space, nature would respond in multiple and very complex ways. But it's very, like whenever I go to the field and I work with the line officers, the thing that I tell them is that don't do any intervention. This is my first strategy. No intervention, just leave nature like that. I only say put marking pillars and put a sort of periphery, what you call the boundary. I say if you have budget for just putting boundary, then wetland would take care of itself, like just. So it is a small presentation, so I have to press the red button.
Stick to about 10 to 12 minutes.
Yeah. So a very brief introduction on what are the ecological functionings in our water bodies, particularly the nature of water body, the trophic state, and the diverse biota that we deal with, particularly algae and macrophytes. Challenges they are facing, and some few cases, I have not, because of paucity of time, just few cases, glimpses on what we have been trying to do. And I say wetlands are the best NBS. They are the NBS themselves, nature-based solutions, right? They do variety of things, like you see water purification, habitat creation, flood control, groundwater recharge, and carbon sequestration, like alga. More than the terrestrial plant, your blue-green alga is fixing carbon in your marine ecosystem. So how could you forget the carbon sequestration potential of these wetlands? And do we recognize these open areas as water sanctuary? We have national parks, we have forests, we have reserves, we have reserve forest, but we don't have any water sanctuary. We don't have any fundamental rights to water. So can we have certain areas
which are designated at water sanctuary. If you go to like some parts of, like I was in Belgium, and they have this critical aquifer protection areas, they call it CAPAs. They demarcate it and then don't allow any human activity on that critical protection area because they are the recharge zones. And you don't put pesticides and herbicides on those areas. So, and secondly, the nature of water bodies itself. Have we actually studied these nature of water bodies? We just go and intervene without knowing that whether it is a wetland or a lake or a pond or a swamp or a marsh. You just go and do with mechanical dredging and you destroy the entire biota, marginal vegetation. So we have to briefly understand that rivers are the drainage channels and the lakes could be of several types, but generally we deal with the alluvial lakes, which are basically created by tectonic events, or the cutoff meanders and oxbow channels and left scars of the rivers. They were actually carved out by rivers once upon a time. But in Northern America and Northern Europe, they have been recently deglaciated areas. Like in the last glacial period, they got, like some excision and some depression got created. But wetlands are a very dynamic ecosystems. It is the discharge zones because water comes on its own. The soil is fully saturated, and the water inputs from the base flows, from the moisture, it exceeds the evaporation. That's why there is a water, permanent waterlogged areas or the flood area. So they are basically discharge zones. But what is happening? Now these water bodies are becoming recharge zones because groundwater is lost, just like an influent river. When influent river is there, it will be seasonal river because it will give water back to the aquifer. So when the water table comes on the top, like slowly rises up, then there's a base flow, and base flow would keep these wetlands alive. So I say 3F and 3Vs, the free flow, free floods, and fluvial terrace, they are very, very important for any water bodies. And secondly, bank vegetation, natural banks, and the base flows. Base flows is the flow that comes from the groundwater to the surface water or the surface water to the groundwater. It's like a two-way traffic. A water body could become influent or effluent depending upon what type of aquifer is there, what is the permanency of water, and what is the geology, whether it is the hard rock geology or the alluvial geology. So we have been dealing with such rivers where in the summer, the river would be completely dry, ephemeral rivers or intermittent rivers. But we forget that even a dry channel is very important for the hydrological cycle. The droughts and floods are inseparable. They are part of the hydrological cycle. It is in the droughts that the floodplain desiccation happens. The biogeochemical cycling is happening. All the nutrients are getting locked and they will come again during the flooding seasons. So a lot of soil, nutrient, floodplain interaction is happening during the drought season. So if you say that, okay, this river was dry for the last 25 years and we can make a road, doesn't make any sense. Even I say in my lecture or wherever I go, dry river is also good. Dry channel is also good. Dry lake is also good because that is the area where water would be stored maybe when there is an extreme event. So this is the overland flooding which is happening in River Tedi, which comes to the River Saryu in the upstream areas, and the source is a wetland. So sometimes the wetland would also give rise to a river, or a river would feed to a wetlands. So it is a very unique ecosystem. But what is happening? The upland and the coastal wetland and the lake, you see how there is a marked vertical zonation on a very small elevation range. And the vegetation is very unique. You have shrubs, herbs, then aquatic macrophytes, and there are permanently waterlogged, aquatic macrophytes. So we have to understand that if you go through this table, I have made just to train people that how to distinguish between a lake and a wetland, because your approach has to be very different. A wetland has no defined boundary, and the water would keep changing. There's a seasonality of water spread. We call it water recurrence. And in the drought season, in the summer, maybe it will be less than even half of the total wetted perimeter in the monsoon. But we get confused, we say, okay, this is the area and just let us put some, earthen embankment or put some clay and soil and just log that area. Then you're going to kill the wetland. Because marginal vegetation, the edge shoreline vegetation is very, very important for these water bodies. And some of these water bodies are in the interflow between two rivers, variety of oxbow lakes, floodplain wetlands, and interflow meanders, alluvial deposits, braided channels. So they are all part of the river ecosystem. And there's a continuous interaction of groundwater and surface water in these type of, so connectivity of a wetland with a stream is very important. I've already told you this two-way traffic and the marginal wetlands, which are the flood wetlands, and they can alternate between a fully aquatic to a fully terrestrial environment. That is very important to understand because the inundation seasonality is very, very important for the wetland. A wetland has to wet and the dry phase would become, the land phase would become more prominent during certain days or during the summer, and the wet phase would become active during monsoon. So the wet phase and the land phase keeps, like repeating and going on like a cycle. So it is in response to water, and generally the vegetation is very sensitive to these inundation fluctuations. Sometimes when water level comes, you'll see that this kind of vegetation would cover dominance community, and then when the water is even further up, then again a very different type of vegetation would come. So we do a lot of monitoring. I will not go into detail, but we see that these vegetation, even in a small wetland, they are so dynamic that they keep on changing in small time frame. And there is a particular sort of very interesting relationship between alga and macrophytes. Like when there is a lot of nutrients like phosphates, nitrates, then there would be some dominant alga, not from the chlorophyceae, but from the the what you call the red alga or the invasive species, not the native species. Even there are alga which are non-native. Like they grow in a very high, rich contaminant environments, and they replace the native vegetations. So these are some examples of vegetations, and some alga that where we counted many samples, we reported several species. And so what are the major challenges? Basically, the altered water recurrence and flow intermittency. You would be surprised to know that world's 50% freshwater resources are becoming intermittent. And this is a global trend. That means more than 50% of the river network globally has become seasonal. And this trend is also in South Asia because of a lot of pressures and climate change. Then human generated contaminants and nutrients like all sorts of microplastics and herbicides, pesticides, heavy metals. And we have also seen that watersheds are shrinking. We worked on a river and we had the image of previous satellite like Corona 1966 Survey of India topo sheet. Then we saw that some of the smaller streams are getting, like completely eroded, completely sort of wiped out from the map, wiped out. So when we compare the watershed, so watershed was shrinking, but by definition, some watershed has gone to some other river basin, some watershed. So basically we're trying to urbanize the watershed. So the watersheds are shrinking, so their fresh water intake is also becoming less and less, and many wetlands are becoming more seasonal. Invasive species, we have seen many invasive species, one dominant species sometimes would wipe out the entire native flora. And a lot of restoration efforts that we are doing is ad hoc, short-term, reach-based, and quick fix solutions. I say it quick fix because we want to see, okay, before or after picture, we want to show it in just one season. But believe me, a wetland restoration would take at least 5 years. Completely, removal of invasive species, shoreline protection, vegetation resurrection, the natural water resource networking, then connecting with the aquifers, connecting with the channels, all those fourth order, first order, whatever the order of streams to the main channel. So it takes a lot of time, and you have to work on the processes that keep them alive. not on the small, pieces. You have to work on the ecosystem processes or the pluvial processes that keep these water resources alive. We are also witnessing that in UP, in many of the districts where we are working, more than 70 to 80% wetlands have been lost in the last 50 years. This is a data which is quite shocking. And second fact is that 90% of these wetlands, they do not come under protected areas. Like we have national parks or inside the sanctuary. Ramsar site is assigned more than 89 or 85. But the smaller wetlands, they are not even in the revenue records. They are written just like water body. If you go to a district magistrate, you will say, okay, I'll check with the Sajra map. Then in the Sajra map, the original water body, which was 180 hectare, will be 80 hectare, 100 hectare gone. And you will not believe on those satellite pictures and Survey of India topo sheets. You will only believe in the revenue records. And these revenue records are being changed on a daily basis. By your local Lekpal, Tehsildar, SDM. So what we are saying that first protect these wetlands. Nature will take care of itself, right? First protect it. So these are some of the works that we did. You see the picture in the middle. It was a lake, but what you have today is a colony, very big colony in the center. Then Cham Jheel has gone, Chanoli Tal. These are all lakes. Then there's a lake which was actually part of a river system. And I say it in my city that there were 10 rivers, nobody believes it. But they are recorded in the Gazetteer, British Gazetteer 1904. And they write rivers, streams. They don't even write Nala. So first we converted them into Nala, then fragmented it, and then started, colonizing. So you see this picture. The same picture is there. 1976, and this is 2024. And this channel is a river. It's a Buck River.
It's 3 minutes.
Okay. And so what we are doing, we are making decision in a master plan 25 years, in a regional plan maybe 5 years. Who is bothered to even think of 100 years horizon? But I say these are our lifeline, water sanctuary. At least you plan for 100 years. After 100 years, this water body has to be like a water body, right? So this is a tal in the previous picture that we created. It is called Pragya Tal, a constructed wetland in my campus. And then this is the retention pond. It is called Karuna Tal, and there is a Sheen Tal. So we are trying to restore the historical drainage pattern even in our campus, because this campus was, half of the campus was wetland. So I convinced my vice chancellor that, okay, let us restore some of them. So he agreed, and in our logo, there's a Karuna Pragya Tal. So I said, okay, let's name it like Karuna Tal, Pragya Tal, Sheen Tal, and it stores a lot of fresh water. And this was a river, the part of river that I was talking about. You see, we tried to restore it. This is the picture in the lower 2017. And this is my colony where I stay. I convince people that look, this was once upon a time a river. But now since there's no record in the revenue because everything was changed, I'm having a very hard time to convince local mayor, municipal commissioner, and even the DM that this is a river, 58 kilometers, and half of it is still there. And there is a ephemeral channel, paleo channel is there. And this is an important drainage point. We are forgetting that during flood, half of South Lucknow would be flooded because this drain is now totally encroached. So these are areas where we are working. We are using hybrid approach, using NBS with some floating bubble aerators. We are also doing constructed wetlands. This is the Moti Jheel 15 years back, and you see what happened later on. The entire Jheel got wiped out. So we are working on this Jheel with a mixed approach. Then we also tried to do in-stream habitat improvement. We convinced farmers to just leave 50 meters on both sides of the river, which was tilled. I said, okay, you have to leave some land for the river. It is a terrace of the river. You can't do farming. Otherwise, you destroy the entire river. So they got convinced in Pilibhit, and they left some of these lands, which we tried to restore it. And we didn't plant anything, just it came on its own. Shrubs and, shoreline. Shoreline vegetation protection is the first step that we do in the rejuvenation of rivers. Then this was the drain. Now nobody dares to call it drain. Chief Minister intervened and he said, now it is a river. So we got it recorded back as a river. This is a 28-kilometer long river, which is a tributary of the Gomti River. And this was very fragmented. We tried to, redo it depending upon the satellite pictures, and we connected many vegetation islands with the channel. And we also planted these macrophytes, mixed macrophytes like Pistia and Typha and Phragmites. So the mixed macrophyte was giving better result. Although I say don't plant anything, let it come on its own. But sometimes we do have to intervene. Like we tried to do Typha, but it was all gone in one flooding season. So if the flow rate is more than 5 mld, it is also a problem. But it comes on its own. If you leave it, there is no grazing, then the channel. So my last 3 slides, I'll conclude that we have to first work on the hydrological restoration, that is reconnect the floodplains with the channels, with remove the barriers or the embankments, especially on the smaller channels. Even I don't like the check dams. Everybody likes check dams, but have you ever bothered about the downstream communities? You stop the flow. What happens? The river becomes dry for almost 50 kilometers downstream. So a river is a running ecosystem. Then rewetting of the drained wetlands by water table, retention ponds, base flows. So entire wetland hydrology has to work upon. Then stormwater management like retention basin, constructed wetlands. And secondly, vegetation restoration, try to restore the native vegetation, go to a very wild patch and bring back those mosaic of vegetation. We did for Kukrail. We went to the very wild site and we picked up and we raised nurseries for those plants, right? Then invasive species is very big problem. You have to uproot it and plants, do the soil treatment and do the natural plantation and buffer zone development, riparian buffers, that is the shoreline buffer, the terrace. And finally, the sediment and nutrient management. That is sometimes we also put wooden chips, like a wooden chip in a fiber and put it across the lake. It stops a lot of nutrients from simple, like technique, sediment trapping, then bioengineering, wire logs, wood chips, sediment traps. So this is all I have to say. Thank you so much. This is a very natural lake, Kurseli wetland. Thank you so much.
Thank you very much, Venkatesh. While Anushka introduces the next speaker, thank you so much for setting a good frame and giving us some kind of a, I would say a very good 101 kind of course on how to look at wetlands and ecosystems. Thank you, lake ecosystem. We'll call the next speaker. Thank you.
We are pleased to introduce our speaker, Mr. Akash Hingorani, a renowned architect and urbanist dedicated to creating sustainable people-centric cities. As the lead at the Oasis design, he focused on tackling urban challenges such as pollution, congestion, and environmental degradation. His work integrates nature-based solutions, ecological restorations, and sustainable transport infrastructure to transform urban spaces into resilient, thriving environments. We welcome you, sir.
Akash, welcome, and around 15 minutes, if you don't mind. Thank you.
Okay, good evening, everyone. Thank you so much for having me here. And I have quite a few slides. I'm going to just quickly rush through all of them. Mostly are visuals. One disclaimer, I'm not a technical water expert at all. I happen to be an architect and an urbanist, and we do projects where essentially we look at learning from all of you and experts and trying to kind of put all of that learning into our projects. So I'll just have to rush. So what the city wants is, in terms of all of us, the dreams that we have, and actually what our cities are turning out to be with increasing pollution and all of that. So how we think blue-green has to be part of the system, and then the whole idea of systems thinking, because if you're looking at one problem and you can solve it, but if you have an opportunity and you can, kind of do all of this together, that is the idea. And we've been working across India, and with sustainability as the backbone, we focus on mobility and water. And in that, street design and parks and waterfronts and greenways and smart cities. So that's across the board, like what we do. And we also kind of have contributed to many policy guidelines in the country, be it for rainwater harvesting along streets or, showcasing how water is an important part. And of course, we do all of these. So I'll just skip all of that, and then how we started our work and how we, in a particular project, started looking at water and designed a lake, and then took all the stormwater from that side into that. And then, there were these first experiments where we were not like fully successful. Then slowly, we started understanding the nuances. And this is a sponge park that we have done in Delhi, where there were these two existing trees, but we dug out everything around that, kept the trees the way they are. And finally, this whole park actually takes in a lot of stormwater, and you don't even realize. So NBS at work, but it's like integrating it with design. So we've also looked at many solutions where we're looking at possible drainage channels in different cities, and how. So this was a whole project that we conceived around a particular so-called nala or a drain, and reviving that and using the wastewater treatment systems like DWATs and phytorid treatments, and then actually understanding where we need to do what kind of treatment, and then kind of imagining a new urban realm which is more some place where you would want to go. Now, in this particular project, we work with IIT Delhi to understand all the mechanics that all of you understand here. But, then pool and riffle systems, so sedimentation and aeration happening, increase of the cross-section area. And then we had this project where a particular lake was completely dried up. And then we worked with a sewage channel and then treated the water to fill up the lake. So this was with NEERI. So this is what the project looks like. I mean, how the different treatment facilities, including phytorid, all happen while while the landscape kind of starts shaping up and makes it a usable space for the city. And that, of course, is the quality of change of water. And so the clue that we got was the pollution in the water is actually food for plants, and like how best to, so we actually drew up this whole thing, and luckily got implemented on site. And then we, of course, do a whole lot of, mainstream projects like public parks and, for the Sabarmati riverfront in Ahmedabad. So all of this, and then we have done one of our most prestigious projects is the Lal Chowk in Srinagar. So this was an old square which we completely redesigned from what that was to what that is. You can notice even the main clock tower is now more representative of Kashmir and the syncretic architecture there. And then, of course, so what I'm saying is placemaking is something that is the mainstay of our work. And what I really want to dive into is this project that's about eco-restoration of lakes in Coimbatore. So we got a chance to roll out this mission, and this is already clocking so many awards as a project. So there were like 9 lakes which we had to study and kind of restore. So there was this like a cycle track that would connect all of that. And the whole idea was restore, regenerate, and reconnect. And how these lakes, which were earlier kind of created for irrigation, so Coimbatore as a city, I mean, it's just at the foothills of the Western Ghats. And there's like a horseshoe formation of hills around the city, and all these channels come down from the hills onto the river Noyal, and all these lakes were like, intercepting that water before it goes away. So this was like more than 1,000 acres of lakeland and about 30 kilometers of the connecting cycle track that we wanted to, that was part of the brief. And then we worked with CDD and their whole team of experts, trying to map out the entire, the cascading system of these lakes. So each one flows into the next one. each lake, the catchment area of that and what kind of, water we are expecting. There was an aspiration of the city that they wanted us to kind of, have the lakes filled with water at all times. So CDD did all these calculations of the evaporation loss and percolation loss, but this is what we actually got when we landed there. So it was quite a sight, and I mean, we had to be, remind ourselves that, okay, we are on a mission here. And I remember walking all these places with Andrews and, so, I mean, it was in a bad shape. And to the extent like some NGOs had done previous desilting drives and created these silt mounds, which would block the view of the lake, which we had to study and, kind of remove. And then also looking at the Indian scenario for possible projects to learn from, all the waterfront development projects were all hard edge. And here we were like, wanting to try ecosystem restoration and all of that. So like trying to learn all this from other people and bring back nature-based solutions to, as a thing for the main project. So this was like the determination with which the whole team went after this project. So we mapped all the inlets and, figured out a way that how we're going to merge those two inlets and create some kind of a wetland and a primary and a secondary treatment. We figured out which were the main bunds which, need to be higher and stronger, which were the ones which we could kind of lower. And while lowering this, imagine like half the city would come out and tell us like, these guys don't know what they're doing, our whole city will flood up and this. So, I mean, we had all kinds of challenges, you name it. And then going in for this, again, first of its kind in the country. I mean, there would be engineers who would tell us that you have to do hard edge, this will not last. And, so erosion control and slope stabilization techniques, putting in revetment, the size of the revetment, explaining to the contractors what has to be done, how it has to be done. We would stand there, like my wife, I remember, would, actually get all these stones placed by the big cranes, like the way it had to be to make it look natural, putting in a plant layer, like what somebody was saying, the mixed kind of, planting palette, again, working with aquatic plants on the slope itself. So, and we had to work with contractors who were coming from an experience of making roads. So they did this and they lowered the bind, marked out the thing, and they told us, okay, now just give us one section, we'll just roll it up, thinking it was a road project. And we said like our section will keep on changing every meter. So sitting and explaining all this to them, getting it done on site, and finally, that barren piece of land I showed you with some level of planting, gave them the planting, species. We worked with only native species. There was a biodiversity expert on the team who would identify what plants are we supposed to use, looking at the palette. And then this lake, once upon a time, used to be like this. I mean, when we found it in the first instance, half of it would hold water, half of it would be dry, except, during monsoon. And the aspiration I told you was so the inlet situation we want, and this is now, of course, so I'm just telling you like what it was and what it is. So the idea was like how from the inlet, if we could create a wetland kind of a thing, which would, essentially be shallow depth water. And that time we understood that the shallow depth would be good for birds with, smaller birds to come and kind of nest. So here you can see the whole wetland, that dry piece of land, we actually dug it out. And then when it rains, the water actually starts filling it up. And this is what you see, so we had all these big kind of explanation for the team. And of course, the CDD team was absolutely brilliant in the way that they went after every inlet and mapped out the pollution and the, and then came up with the solutions. And then the whole idea of doing wetland. So they would size up the wetland and we would actually sit and design the shapes to make each wetland like different from the other, because we had 7 lakes. We wanted like, some level of variety while we were doing this, technically doing the same thing, but in terms of how that space would read, and even maybe play around a little bit with water. So you can see the kind of change from what it was and what it is now, and putting in wetlands at the inlet situation. And again, a before and after kind of a comparative. So a dried up kind of a lake which was polluted and all that, and today it's like a thriving natural ecosystem. So the whole wetland, how levels, how all of that was organized, and in a way that we could get the water going from one chamber to the other. And there were some lakes which were slightly more ecological. So again, like what you see up there is what it was, and we kind of had to do like a wetland system because there were two inlets on both the corners. So again, how each and this is a lot of technical back and forth between the water expert team and the design team here. So trying to, and then of course, once it was done, then we had floating jetties and floating wetlands, and birds started coming in, and all of this, like the native birds, which would automatically come in, carbon sequestration, somebody talked about. So even smaller patches, they can see the difference, all that land which is there, this lying barren, derelict land was programmed, and it looks like this today. If you go, so the whole approach was a very light-footed ecological thing, prefab gabions, floating local stone and bamboo, and a lot of container architecture. We had an urban design kind of thing with these markers, and how the area now, with all the planting in place, what it looks like now. This was the band which we kind of cut off and then brought it down and opened up the view. And there were some people who told me that you displaced those cows. So we brought in a lot of wildlife to balance out. So, I'm sure they'll find some other place to do sun tanning. This is what approach for bringing in nature into a city. And then we added a little bit of fun elements and, a few kiosks and what a road like that, which was bisecting the lake. We, created the lake edges, added elements, put in floating jetties. There was a space under the flyover, which we, kind of completely revamped. It was like one of the crazy negative spots in the city. And so we analyzed the view cones and the potential of the place, and then figured out a way to do it. So it was like this, and we made it into something like that, full of garbage and unused, and people who do all kinds of things there. And today it's like one of the most popular cultural hubs that the city, everybody wants to go there. And there are music shows and festivals and you name it. And then we didn't have space. So we put in this like a floating pontoon deck, because we had to connect to the other side. Children's play areas, now people enjoying the lakefront. And this is what gives us the maximum joy. Fine, bringing in back biodiversity, all of that, I understand. But, when people also start owning the place and, getting to enjoy the entire lakefront with laser shows, lantern festivals. So this was the project. Now, looking at...
do you have a lot more? Or?
No, another maybe 5 minutes.
Okay.
So, just ending, because I wanted to, bring back the discussion to how in the city, how the roads, in terms of drainage. So we understand like, how this is also a big problem that we have. So we actually figured out a way to bring the stormwater. So when you say blue-green, the blue actually doesn't meet the green in most of our cities. So we have to lower the green, and we did a whole lot of detailing for that, put in a handbook. And, actually taking off, this is Ring Road in Delhi, taking off unnecessary service roads, bringing in, softer swales, so that stormwater management, cycling, walking, and this is what a swale starts looking at. So nature-based solution in action, being done, and it looks perfectly fine. You wouldn't, this is a roadside, again in Delhi, and it actually incorporates all these planters are lower, and they all incorporate a rainwater facility. So like rain gardens coming in, and it doesn't even, this is a race course road in Coimbatore. So, and how people now use the same space. And thank you so much.
Great, wonderful. Okay. So I didn't feel like stopping you with all this. So it was, I think, a great expo. I mean, if there was a presentation yesterday, you were not there. It was called the K100 Drain Project, and that was seen as a very large scale pilot of drain rejuvenation. So if there is another big K100 equivalent, it's the Coimbatore 8 for lake rejuvenation. I would say the 8 lake, 9 lake rejuvenation project in Coimbatore, which is part of the smart city, costing almost 500 crores thereabouts, right? And there's no bigger pilot like this that you can find in the country as a whole. So Akash, I mean, we had the good fortune at CDD to work with Akash on this. So wonderful, Akash. So I think we can call everybody. Akash, you can take your seat here, right? We'll call the other panelists also.
Yes. We are pleased to introduce our first panelist, Ms. Usha Rajgopalan, a writer, translator, and dedicated lake conservationist based in Bangalore. An award-winning author across multiple genres, she has received accolades in Commonwealth Short Story Competition and the Federation of Indian Publishers Award. Her passion for environmental conservation led to the revival of Puttanhalli Lake, co-founder the Puttanhalli Neighborhood Lake Improvement Trust. Currently a Homi Bhabha Fellow 2023 to 25, she is documenting her journey as a lake conservationist, continuing to inspire community-led environmental stewardship. It's a pleasure to have you amongst us, ma'am. Please give a huge round of applause. Our next panelist, Ms. Lata Raman Jayagopal, an architect with over 3 decades of experience in sustainable and inclusive design. As co-founder and director of Inspiration Collective, she has led over 600 projects integrating ecological sensitivity into the built environment. A founding partner and past president of CDD India, she has been instrumental in advancing water security, sanitation, and environmental solutions. Great to have you here, ma'am. We are pleased to introduce our panelist, Ms. Shashikala Iyer, a leading conservationist spearheading WWF India's wetland program in Karnataka since 2016. She has played a key role in restoring wetlands and river ecosystems across multiple states, including Telangana, Andhra Pradesh, and Goa. Her work extends to policy advocacy, supporting the designation of Ramsar sites and developing integrated management plans for sustainable wetland conservation. Excited to have you here, ma'am.
Thanks, Anushka, for the introductions. So I will start with Usha, because I heard you also had some slides to show, right? So if you could talk about your Puttanhalli experience with your slides. And it's going to be short, so we can take a quick look at it.
A very good afternoon to all of you. As you know, I'm basically a writer, so I like to call myself a writer by choice and a conservationist by chance. And it is that part of it which has got me here, because no way would I have ever entered such an august institute in front of an august gathering. I am the least scientific person that you could ever think of in this place. So without much ado, let me tell you about, I came to Bangalore in 2006, thinking I'm going to now take up writing full time, because I had already published 3 books and my children had grown up, they had moved out. It was my turn for myself. But what happened was, I happened to see this lake. First time staying in the 5th floor of an apartment complex, and this is what I got to see. I felt guilty that if I kept quiet about it, then I am as responsible for the lake dying in front of my eyes. So I mooted a campaign in my apartment complex, just simple, Save the Lake campaign, because I believe in people's power. So I campaigned, the campaign flopped big time because people said it is the responsibility of the government, it is the political real estate mafia, and why are we paying taxes, so on and so forth. Fortunately for me, one of my neighbors happened to be with the Bangalore Infrastructure Development Agency, and he got the municipality, BBMP, to take up the lake for rejuvenation. So this is how BBMP started reviving the lake in 2010. And this is how the lake looks today. And this is largely because this is not really Puttanali Lake, we call it the People's Lake. It is a community lake. So right from day one, all those trees that you see here, they have been planted from July 2010. We got the neighborhood to come and plant. So you plant a tree, make a small donation. With the money that we got, we hired a gardener, we hired a security guard, and from 125 saplings in 2010, we are now more than 500 trees. And many of the trees, I would really welcome all of you to visit our lake. Many of the trees have the name of the tree as also a board saying donated by, adopted by, in the memory of. So that is why we call it the People's Lake. But here the focus is on nature-based solutions. So I think that I should restrict it to that and not so much of how I got the community involved. So this is what we did basically. We did something called, this is again, when once BBMP revived the lake, and the first thing that came up there was lots of sewage. So what we did was to get this company called Ensign Global. They offered a nano nutrient solution. Please don't ask me what it contains, I have no clue. But in about 15,000 liters of water, fortunately, this is a coconut grove next to the lake, and they had this huge cement tanks. We found it extremely difficult to get a tanker that would take the sewage water, which is the dirtiest water in the dirtiest corner of the lake, transfer it to this. You can see how the water is. So this is the nano nutrient solution that we tried. And I must say it worked very well. So day one samples on the left, and then you have, see, this is how the water was. And then it came to telling the BBMP, this works. So this is the executive engineer and the AEE. They believed it because the proof is there right in front of them, but we did not want to use this nano nutrient solution because it is really, we have seen the lake full of sewage and muck, and it is really like putting a band-aid on a limb that has become gangrenous, you know. So we decided we are going to stop the sewage from entering the lake and also find out from where else we can get new sources of water. So that same company, Ensign, as part of their CSR, what they did was to do a total station survey. And they found out that an avenue quite close to the lake, with the sheer force of water, it could bring the water into the lake. So this helped a great deal, even the lower parts of the area, which was getting flooded, they no longer got flooded. But even this was not enough for us because only about 45, 50, 60% of the lake basin got covered with water, even with this diversion channel, as we call it. In my apartment complex, there is a very good STP, which is maintained by the apartment association. So in order to feed the lake, we approached them to get excess water. They agreed. They said, you go and talk to BBMP. So we went to BBMP. They said, now you talk to Pollution Control Board. So all of us went to Pollution Control Board. And it was a very interesting meeting that we had. So the chairman of KSPCB, so he said, all this is very fine. Now who's going to take responsibility if raw sewage comes into the lake? So BBMP and the apartment association, they are not looking at each other and I'm not looking at my friend. So I just jumped up because I was so fed up of people telling me, where is the water in your lake? It's dry all the time. So I told the chairman, sir, we will have equal responsibility. The STP belongs to the apartment association, the lake belongs to BBMP, and we are the citizen caretakers. Oh yes, I must tell you, we had signed an official MOU with the BBMP, and we were the first citizen caretakers of a lake in Bangalore in May 2011. From then to now, there are about 67 lake groups, and numbers are moving up. And with the treated water, now even that, we had our huge discussion going on in our Lakers group, saying, how can you trust treated water? You don't know in the long run, the sulfates and nitrates and phosphates and whatnot are going to, what damage is it going to do? So within ourselves, we were a little worried, you know. It's one thing to have a lake looking dry all the time and it becoming a football ground or cricket ground for children. But on the other, to have it full of water and then you don't know what impact it's going to have. So what we did was, you know, you see these money plants growing in bottles of water. So that is really our principle. We went in for this floating islands. I saw this also, I think, in some other couple of presentations. So we did this, and our strength is the community and volunteers. So these are people who made these artificial floating islands. Here we used PVC, and we were not at all happy about it. But because we are so illiterate in such matters, we decided let's start off with PVC. And then this is our wetland. Typically, a wetland should be the biofiltration zone, but when our lake is landlocked like ours is, the entire water body is about 10 acres, and the wetland, constructed wetland, is less than half an acre. So there is no way by which the water can meander between the plants and then purify. But with this kind of system, it happened very well. So along with introducing these artificial floating islands, what we did was to tie up with the BMS College of Engineering to test samples of the water. And then later on, we realized, oh no, but they are not an accredited lab. And people will say, no, where is it? We want accredited lab results. So we signed up with a accredited lab, and we have been testing the water. But again, we were not at all happy about this PVC. If any of you have better ideas, please do tell us what kind of biodegradable material that we can use. What we did instead was to just go for the ordinary bamboo ladder. This is our latest experiment. We get these ladders, 1,500 rupees, and we put this PVC, this mesh, and then we insert all these locally available canna and things like that into it. And this is, as you can see, it's a very, very new experiment. Our gardener was also very, very, they got into the flow of things though. So in order to aerate the water, what they did was this AFI model itself, this guy used the water, we rigged up a pipeline because we found our gardeners were spending the whole day just watering. So we said, no way are you going to waste your time like this. So we got them to rig up a watering pipeline all around the place. You just open the valve and then the water flows. So they have no more excuse to say, madam, I couldn't sweep because I was too busy watering the plants. So with that same pipeline, this fellow rigged up this, and then he went on to, oh, I'm sorry. This again. Yes. So this is again using the lake water. But at the end of the day, this aerator fountain is the best. And this, incidentally, was our retirement gift to the chief engineer at that point, who was instrumental in making me and my friends lake conservationists, and also so many of us lake conservationists.
Right. Thanks. Thanks. Yeah, so we'll properly begin our panel. I want to invite Venkatesh Datta also to join. Sorry, we missed calling out his name. Venkatesh, please come. I think for the panel discussion, let's focus on NBS approaches, and I think I'll start with people who have not spoken, Sashikala and Lata. And let's, while Venkatesh's presentation covered the whole gamut of water bodies, including rivers, streams, and rural-urban context, we will probably try and stick more to the urban context, just to give some focus to this whole conversation. Because the urban water body challenge is a bigger challenge than, let's say, in some of the less urbanized areas. While it's a challenge all over, I agree. So based on that, Lata, I want to tap into your, Lata is also an architect by profession. So just like Akash was a landscape architect, the architects are good at making placemaking. So how to integrate water body rejuvenation and people's participation with the idea of placemaking is something Lata has also experimented with a project in Alleppey, right? And if you could highlight what kind of nature-based approaches you and what did a nature-based approach mean in the context of the Alleppey project for you, and how is it sustaining itself today? And if it has scaled up, now you can explain, and if it has not scaled up, what kind of limitations did you see and why it has not scaled up?
Yeah, thank you, VG. And yes, I wish I could also present, but then I'll just explain what the Alleppey Canal project was. It's actually started with looking at rejuvenating the canal network of Alleppey. Alleppey, I think at least many of you know it's known as the Venice of the East and all that. But unfortunately, the entire canal network of Alleppey is almost dying. So when we actually got an opportunity to look at it, so it started off as rejuvenating the canal network, and Alleppey essentially had two main canals. And just like what was said earlier, normally rejuvenation projects are just looked at from the cosmetic point of view, where you have the bigger canals, you do a little bit of space making on the sides of the canal, bringing little landscaping steps into it, some gazebos and stuff like that. But because I've been part of CDD since early 2000 onwards, and we know that you can't kind of ignore the fact that just beautification is not going to be a solution. We thought that we will look at it from addressing the pollution point of view to be sustainable on the long run. So when we got started, actually, we decided that when you look at the main canals, often they are the most visible ones, and they probably don't have, because a lot of people are looking at it, there's not much of direct pollution into the bigger canals. But you cannot look at the canal as the bigger canal in isolation, because ultimately it's a canal shed, which is the terminology that we eventually came at, where the bigger canals, or the bigger nalas in whatever way that it's called in different parts of the country, are often fed by smaller sub-canals, and the smaller sub-canals are fed by another smaller set of networks. And ultimately, all these are stormwater management systems, particularly in a high water table area like Kerala. These all used to be ultimately earlier, many of them used to be navigable. The smaller ones would actually feed into it, mostly as stormwater drains. So when we actually got started we documented the canal shed entirely, most of which unfortunately, other than the bigger canal and some of the sub-canals, are all reduced to drains now. And we realized there were two or three things. One is that there is very little mapping, as was said earlier. So to kind of even map the whole thing was a challenge. Then the second thing was the behavior of these canals in monsoon time and in dry time are completely different. And because many of these things are very badly engineered, like what Naresh Narasimhan was also saying yesterday, there are absolutely zero levels, coordination and all those things. So we had to look into it. The third thing is that most importantly, we felt that the pride in water bodies, the pride in our natural heritage, like you were saying that you felt bad. But ultimately, when we go to Alleppey today, what used to be beautiful canal networks, every shop, every restaurant would have their waste lines going into the canals. There's not one place where you would find that the restaurant is actually overlooking into it, whereas it is huge potential. So ultimately, we realize that unless we bring back the pride in the water body, we are not going to be successful. And that's what, as architects, we would like it to be revived back. And then, of course, you need to bring the community together. So we did this exercise that we thought that, and of course, it needed a champion who I shouldn't actually forget. This was one of the persons who kind of really supported us was the then MLA of the place, who was also the finance minister of Kerala, Dr. Thomas Isaac, who actually is a very champion of people's participation and all. So it was integrating 4 or 5 things. One is looking at it as a canal shed. Second thing is getting community participation, bringing back pride in the commons or natural heritage, as one would say, and trying to treat this pollution as close to the source as possible. But with this basic approach, what we did is that, and then of course though we were looking at the overall canal rejuvenation project, people wanted proof, like what are you really going to try to do? So then we said that, okay, we'll take a pilot project, which was a 2-kilometer stretch of a sub-canal, because we wanted to treat the sub-canal and show that once you improve the quality of water there, and then there are 14 similar sub-canals, if they could be treated, then finally the water that is flowing in the main canal could be improved. So we took this, and so therefore, because we thought that it had to be a prototype which had to be replicable, we actually ended up identifying about 10 or 11 replicable interventions. First, I just say the names of it and then I can. So first one was, of course, physical cleaning of the canals, which is no-brainer, because none of these canals would ever, I mean, particularly the sub-canals, had never been cleaned at any point of time, I think. So you have to, and also brings in the fact that you cannot separate solid waste from liquid waste because you're both entering into the sub-canal. The second thing was trying to understand the catchments and the drain mapping. So correct. Ultimately, as I said, these are stormwater drains. To ensure proper flow, we had to really map the drain and take into care of micro as well as bigger choking points or hotspots, as we would call in stormwater. Then the third was identifying the liquid waste that is flowing into it, quantifying and qualifying. And then generally, I think in most states, you do have rules for bigger discharges. Like in Kerala, it is like anyone who discharges more than 10 KLD or 10,000 liters of water per day in the private sector are supposed to have their own treatment systems. But there are also bigger, so that was the third, identifying those bigger hotspots in the private sector. And that was more like liaising with the Pollution Control Board and ensure that they were setting up their own treatment systems. But there are also larger polluters in the public sector, which the local body has to take care of. So we identified those which included one market, included one slum colony, etc. And for those, ultimately the local body had to set up something to kind of treat their wastewater and let it flow back. Similarly, there are hotspots in the solid waste also, the bigger private sector polluters, identifying them and ensuring that they comply. Larger polluters of solid waste in the public sector who had to be handheld. Then the smaller discharges, like you have, so like a household or a small restaurant and all that, right now there are no governing laws. So that is a little bit of a gray area. So the only thing that we could do is that we try to set up demonstration systems for liquid waste management as well as solid waste management, so that would help the local government to make it into a set of either like fully subsidizing depending on their income group, partly subsidizing, or through enforcement for the larger commercial or big houses and all that. Then we try to bring in this thing of pride into it. So we try to do a lot of graffiti and bring in very interesting dustbins or good lighting and all that. So you start getting people to feel more happy about their water bodies. Then we had to involve the community at every level. So from day one, there was also a campaign which we worked with the local youth of Alleppey. It was called, the group was called Can Alleppey, and we had a tagline called Thoda Ode Alla, which in Malayalam means, maybe probably, it means the canals are not drains. So this campaign went on. They had a lot of social media presence, looking at polluters and all that. Eventually, it moved to organizing canal committees. So within this 2-kilometer stretch, we formed like every 200 to 300 meters, the local people would form a small canal committee, and they had to kind of take ownership of the cleaned canal after that. Then we also decided that for at least 2 years, we had to handhold them. Then, of course, we set up some of the treatment systems, as I said. And we kind of handheld them for at least 2 years so that the community started. And just after this, so this was started just after the 2018 floods in Kerala. And by the time we finished it and handed over, it was almost like the COVID came. So through COVID, but we managed to kind of get them. But today, it's so happy because the community has taken full ownership of it. In fact, the women of the community more, because they were the ones who were facing the challenge of all this mess around them. So now we have a group of women who kind of, and anyone can go there. And the best thing is that out of this one stretch, there's been a lot of positive things, including the fact that the Kerala state sanitation policy has started recognizing such small decentralized approaches as the way to go forward. So those are all the positives. I'll talk about the negatives later if I've taken a lot of time.
Scaling up, do you want to say?
Yeah, I'll just say one sentence about the scaling up. So the interesting thing is that after this one probably very successful model, which, and in fact, Alappuzha municipality won the Swachh Sarvekshan Award in 2020 for best practices and all that. We thought it might be an easy way to scale it up because this was done through a CSR initiative. So it was very easy. It was just, it cost us yesterday, Naresh said about 175 crores. We spent less than a crore to actually make this happen. There are much smaller, softer interventions. So with probably just about maybe 20 crores, we could have easily tackled this whole canal rejuvenation. But unfortunately, see, local governments, decision making, I think governance, decentralized governance is a big stumbling block. The local body is the one who benefited out of it, but the local bodies don't have any role in kind of taking decisions, as has been said by so many speakers. There are multiple agencies who are involved in this. There is irrigation department, the local municipality, PWD, Swachhita Mission, all that, some 10 departments to kind of, and they all work in silos. So to kind of get a consensus between them, the local body doesn't have a final say also. And also that ultimately, I'm sorry to say, but it is mega projects which are more appealing for all governments, whether it's a state government or anyone. So as somebody was exactly saying, I don't remember who said that, while this worked beautifully, I think it was in the morning, there's in Bhuj, there was another like 30 crore. So in between, the water authority or somebody comes up with this 150 crore sewage treatment plant for Alleppey and all that, which by all practical means, we know it's not going to work with this very high water table to get the sewer lines and all that. So I think the bigger challenges, I felt that it was not that the technology didn't work. It was not that people didn't believe. It was not that it was not possible within a certain budget or anything. It was just that the difficulty in taking decisions, the attraction towards mega projects.
The political economy and the institutional nightmare.
Yeah, institutional nightmare, exactly. And the lack of receptiveness to out of the box ideas.
Great, thanks for that wonderful summary. I mean, one can easily see from this that nature-based approach is not about a technical solution. It's a whole approach, and I mean, you could extend it to involving the people, the community, and how do you do it with least gray infrastructure, but doing minimum as required, and so on. With that, I would like to move to Sashikala, and I understand your organization, WWF, is more into community engagement, public outreach, and to promote biodiversity, wetland restoration, and so on. Could you share your experience of what you do, and particularly how you are able to get people as a contributing force in this whole thing? Because many of the whole last 2 days, people were singled out as a anthropogenic factor in why this is going, why everything is deteriorating. Right? People are the prime cause. And how do you convert people into a force of nature? Have you been able to do it? If you could, yeah.
Thank you. So when we started our work in Karnataka, basically, so there was one lake which I feel proud to talk about, because that restoration, we call it like a community-led wetland restoration. So this happened in Bangalore rural area. So you have this state highway, and there is Bashetali Kere. If you are from Bangalore, please go and visit that place. So when we started working,
which direction of Bangalore? Which part of Bangalore?
Bangalore rural.
I know.
Doddaballapura. It's in Doddaballapura. So when we started working there in 2016, we have 2-3 pictures. I'll request Rohini afterwards. We can just show the pictures. It was like people were walking around, and a classic example, like 3 sides, there were industries. It's an apparel park, and one side was a village, and there is a highway also going there. So when we went there and we were just walking, and where is the lake, wetland? This is the lake, we are standing on the lake. So there were like all type of things happening, and there were small puddles where a little bit of water is there, and people are playing, enjoying, and walking across. Everything was happening there. So the first thing was like how to start, where to start. So the first thing what we did was we started talking to people. So there were like different factions of people like industries association, then local community, then government agencies, like say replicate like many government agencies. And we started taking their insights on what happened actually. And just to remind you that Bashatelli Kere is the sub-basin of Arkavati River, which used to flow many years back. But now, like we just read it, like there is an Arkavati River here. So this is a sub-basin, and again, that's because that's again becomes a very important wetland to flow into that Arkavati River. So when we started talking, we got to know that the farmers were blaming the industries because these industries have come and they are polluted this wetland lake and it's gone. And the industries instead they were blaming the villages that they are doing open defecation and they are not taking care, they are throwing their solid waste. That's why this is happening. And the government was like, this is like, I don't think this is going to happen or anything. So what we did was we formed a multi-stakeholder committee, multi-departmental committee headed by the district deputy commissioner and district magistrate. He is the head of the Bangalore Rural District. So we made a committee where all the departments heads were part of it. And also the Industries Association was part of it, the local community, the Gram Panchayat, the Taluk Panchayat, everybody was part of it. And then we started talking to them. So the first thing was we started talking to them from the starting. So from the start of the project, they were all with us. And we were the technical partners. We gave technical and scientific inputs like how to do it, what are the studies which needed, like geohydrology, hydrology studies to understand what is the catchment, from where the water is coming and all. So interestingly, we got to know that there are 4 more wetlands upstream which feed this wetland. And because they are all disconnected, the water is not coming into this lake. So we started working and then we made a rejuvenation plan, which was approved by the committee. It was not approved by me. So the district administration, the local people, everybody came forward and they approved this program. And then we did the actual intervention. So the intervention was, we did contour mapping and then we desilted wherever needed. So it was not like a bowl. It was not desilted like a bowl. So we gave some shallow areas where the waders and like birds who need less water, they were there. And we had like a high like a volume lake. So we had different typologies for different type of birds and which can be useful and which can also feed the groundwater. Then when the work was happening, again, the community was the people who were inspecting and monitoring the work, how it is happening, and every day they will sign, okay, this work is properly done. So there was an ownership. So initially people were like, okay, what will happen? Nothing is going to happen. But in 2019, when we finished the rejuvenation, the first monsoon brought so much water into that lake. And within like a year, the defunct borewells across the villages and the industrial areas started functioning. So like it was not a major, like nothing major we did, but we just brought the water into the lake. It stayed there, it percolated down, and also it helped in the biodiversity. So can you move 2-3 slides? I'll just show. This is the Bashatelli wetland I'm talking. So this is how it used to look at 2006. It's 19.5 acres, 20 acres, yeah. So, so this is how it used to look. And next slide, please. Yeah, this is how it used to, it's looking like. And even now, last year we didn't have a good monsoon, but still it has water. And around people, they are taking ownership wherever, if there is some dumping or something happening, the first thing they do is they go to the Gram Panchayat, Taluk Panchayat, they'll complain and they'll call us. We have complained and this should not happen. So that's the ownership we need for all the lakes if we want to make it a sustainable solution. So that's.
Yeah, thanks so much for showcasing this project for us and your experience of community mobilization and community participation. a quick question to Venkatesh, and after that Akash, and then I'll throw it open to the audience. Venkatesh, all the examples you showed and the framework you set, we didn't see too many of urban contexts or core urban contexts. Land seemed to be reasonably available to wetlands and to expand areas and so on. But I'm sure you have some experience and thoughts on how can you really make a difference. What would be a recommendation on NBS approaches when you talk of wetlands in a scenario of urban water bodies where the pollution loads are high, the sewage flows are high? How would you look at it differently, or the point you made that wetlands is a solution, a natural solution for everything, no need to do anything, don't touch anything? Would that largely work, or do you have some nuances to state?
I think for aesthetics and place making, for connecting communities, some little bit of aesthetics are important. Because that is how you bring people close to nature. So otherwise, there is a wide disparity in stakeholders' interest. When I work in the rural areas, the farmers would want lake to be dry so that they could do cropping. And the fisher folks, they would want the lake to be filled full of water. And those who are doing trapa cultivation, that that water chestnut, they don't want these two guys. So even for a lake, you have to resolve these conflicts with farmers, fishermen, the trapa cultivators. And there's a new pressure from the peri-urban expenses. So the urbanized area eating into the peri-urban core and the periphery. So I work, a lot of my work is in urban area, and the only worry is that these wetlands have not been properly recorded. That is my most worrisome thing today, as of today. Even the rivers, the smaller rivers, like those, first order streams, second order, third order, they are written as drain number 23, drain number 24. But when you go to the village or go to the city, you will see some story that this river was named Indravati or Netravati or Kandavati. So properly naming the river, recording in the revenue records, and also trying to do some aesthetic improvements so that at least it could work as a storm water drain, like during high flood events. So that is very important. So we have identified around 108
So
lakes.
you're all talking about a core city. You come from Lucknow.
Yeah, core city. It's like urban capital. And there are still today 1,370 large water bodies, greater than 2 hectares. So Lucknow used to be like city of lakes 200 years back. There are stories, Venice of Awadh, like there are so many canals and rivers. But during land use change and urbanization, we lost all this water body. So first, the stakeholder consultation, like bringing people on board and trying to convince them, making them part of the entire design, right from day one. And then trying to prove that this would become a valuable asset in the long term. But it is easier in rural areas. Urban areas, it is very difficult to convince people.
Right, but the solution in terms of wetlands would still be a go-to solution even in urban water body rejuvenation.
In urban areas like wetlands, earlier the water table was very high, so it used to be perennial. But now the shallow aquifer has gone down. Shallow aquifer is dry, so these wetlands have become seasonal. So we have to reconnect some of the smaller drains, rivulets, that is inlet, so that there is a water permanency. Otherwise, leave like that. At least some vegetation is there, some biodiversity is there, and they are working as a retention structure during the extreme events.
Great, thanks. Akash, one question to you quickly. I think you had the good fortune, whether you've been fortunate enough of doing all this, I don't know whether it has increased your fortunes or not, but you had the good fortune of working for more than 10 years, starting with Sabarmati, then Pune and various places, and Coimbatore being a feather in your cap. But over the years of more than 10 years, probably, I think, how has your own approach evolved? I mean, earlier, I'm guessing it would have been pursuit of more like waterfront development, aesthetics, and the placemaking would have taken prominence. I'm seeing that it is there even now, but has anything fundamentally changed to make your approach more nature-based?
loaded question. Anyway, see, like I told you, the disclaimer, I am not a trained water person. I keep learning from others and then trying to incorporate these solutions. The first project that I worked with was in Delhi along a 13-kilometer long drain where some, the community ladies, they were like very active and they formed an NGO and they would visit this place and they would complain that there, this sewage problem. So they collected a lot of money from the residents and they wanted to put up a wall which would hide this particular drain and all the problems with it. So when they called me that as an architect, they were thinking, I could probably help them. So the first thing I told them that don't do that. That would be a disaster. You will only aggravate your problem. It will become worse off. And give me some time. I'll come back to you with a better solution. And then we went and studied the Osho Park in Pune, which was one of the very early examples of how nature, could help with treatment. So with that kind of an idea, we decided to do online treatment in the train itself. And then this project, of course, became much bigger, the entire length. And then we worked with IIT Delhi, what I was showing you with what treatment. So understanding that nature has a way to kind of, fix these problems if you allow it, the necessary conditions. And so that's been there for us from the beginning. And then there was this problem, like all our cities, even today as we talk, all our cities are flooding up. So we don't know what to do because increased urbanization and increased runoff, where does the water go? So while we were doing street design, then we realized that nearly, streets are 25% of your city area. And if you count the abutting properties, nearly 50% of the stormwater is flowing through your streets. And if you just take the conventional approach of putting in roadside gutters and digging in them, so obviously, the system is going to get overwhelmed. So if we can bring in some kind of a recharge mechanism with NBS, with rain gardens and swales in the landscape, what I was showing you, so that helps you to, kind of look at both the things. I mean, beauty has never been, we've never been impressed by, just skin deep beauty. It has to be from within. And it's only when beauty is working inside, which many may not even realize, but that for us is true quality.
You also developed a manual for the DDA, I think, right? Or on stormwater drainage. Is that being followed a little bit?
Yeah, so, there was this, when we were doing our work with street design, there was no manual even for street design. So like we would go and tell them curbs have to be 6 inch high and they would say, where is it written? Why should we listen to you? So we realized the need to, kind of put in a manual. So that was a street design manual. But then when this water thing happened and we started understanding that the green on the road is actually higher than the road and the water from the road can never touch the green. So there's no blue-green integration of any kind and the green is just sitting there looking pretty, not doing anything. And the water has to fend for itself. So that whole standard was about how to make these green areas lower than the road so that the stormwater can go inside the green and the green therefore can, help in handling the thing. And that handbook we prepared for DDA and it got accepted in Delhi. And then now it's part of IRC. There's a new Indian Road Congress guideline on stormwater drainage for the country. So, typically when you're doing projects in the public realm, all your engineers, government departments just ask you, show me the rule book. So it was so important to get this added in that thing.
Oh, wonderful. That's great achievement. Okay, we'll throw it open for maybe 2 or 3 questions. I think, okay, sorry, please go ahead. Sorry.
So I just wanted to say 2 things. After the Bashitali, like you said, how it was taken.
Scaling up.
Yeah. So the best part, what happened was everybody took an like a note of that this can happen. And the Arkavati project which we are working right now, we are looking at so Arkavati till Hesarghatta is a cascade of wetlands. So it moves from one wetland to another wetland. So till Hesarghatta, after that it flows like a river. So we are trying to build the connectivity, bring the connectivity back so that all the lakes, wetlands get filled up, and then it can have, and the side, the sub-basin and the other feeder of wetlands also get big. And what happened was, because of Vashetelli success, even government was like, you tell us like what to do, how to do. So it's not like they don't take like your expertise or technical, because if they see that something is happening, so definitely there is a chance that there is an uptake from the government side also. That was one thing. Second, can you show that picture? One of the thing which we are trying, so it's like floating islands, Usha already said. But other thing is floating fountains. Again, we have tried in one of the wetland, which is like Doddaballapura town. So you see, just see one. So again, there's a Nagarkere wetland. So it is in the center of the city. So it has all the problems which our urban cities have. So floating fountains we have put because the dissolved oxygen was like 0 in the lower strata. So then we thought something to do. And this is not for beautification, but it's technically needed. But one thing which we added was we provided solar panels, which provide energy for this to run. Because once we have done it beforehand in few lakes, but what happens when there is a change of government or change of departments, the electricity bill is not paid and it stops working. And like whatever we have tried to get, it doesn't happen. So here what we have done is we have tried and put solar panels which directly provide only to those floating fountains, and it's working perfectly. And they just have to switch on and off. The local community do this, but we are looking for, after 6 months, we will do the testing and we are looking for something like that.
I thought it will switch on at sunrise and switch off at sunset.
No, it's not solar lights.
All right, question to the audience. Yes, that gentleman there. Can we get a mic across there?
I'm Dr. Iyengar, ex-BIRC. Settled down in Bangalore for the last 25 years after my retirement. I'm very heartened to see so much of bright spots and in fact very big floodlights on a very murky situation like the lakes of Bangalore, where so much of work has been done, in Coimbatore and UP and all of it. I really congratulate, because at my age, I'm past 80. I grew in Bangalore, but I'm quite depressed these days. Not any due to my own internal problems, but due to external problems. When I go around the city and go around the lakes, etc. But I have not visited the Prasad Shettihalli Lake and Puttainahalli Lake. I'm extremely happy. I would like to visit one of these. But now, this success story should spread further. That is not happening. So I know, coming from a government department, I know constraints of money, resources, volunteering and initiative, and so many things are there. But still, if it can be done, I'm sure it can be done elsewhere also. But only thing I request CDD and all of you could come together and join this a very historic program. I think you should revive the Bangalore, which is once famous for this one. And one more thing, I'm also working on some heavy metal remote technologies in drinking water, etc. The Bellandur Lake I have tested, etc., is one of the worst kind of lake that you can think of. And I don't know whether we are all capable of cleaning Bellandur Lake, but that's a huge challenge. If somebody can take it up, make some initiative, move the government, etc., get the public support. If you want, I will be one of the technical experts if you need. So we can do something on that. This is my appeal and also my congratulations to the team. Thank you.
Thanks for your comments and your encouraging words. So thank you. That gentleman there.
Sir, I am representing KDC. So we are doing, we are executing works, usually works on behalf of government under NGT fund, SBF funds. We are taking up the upgradation of STPs, upgradation of existing STPs and construction of STPs also. Under upgradation, we have used two nature-based technologies for upgradation of the STP. As Venkatesh sir was telling, plants are very effective for treating the wastewater. So we have there are two technologies. One is NEBR technology and another is soil biotechnology. We are adopting. Under NEBR technology, that technology provider using one plant, wetware plant, that itself is sufficient enough to treat the wastewater to NGT standard. In addition to that, he will add some crystals and biobacterial culture. So that is one thing. And others also on the soil technology also, we use some varieties of plants for treating the sewage. I used to take your guidance for you out of your innovation. Any plants which will add value addition for our technology. I will have a contact with you and get information on us on that.
Right. You could catch up with them over IT.
CDD could have invited them also as a part of this program.
Absolutely.
Yes.
You should come to CDD's office and have a conversation.
Yes. Thank you.
Thank you. Thank you for your comments. But any more questions or people want to make comments also is okay. But I would prefer if they can ask questions and keep it short also and name the panelists to whom the question is addressed.
I have a question concerning the operation management to all these nice projects. Once it's set up, how do you ensure it's going to be maintained and how do you finance the maintenance? Could you elaborate a little bit?
Who would like to take up this? His question is on all the good examples that you have shown. How is the operations and maintenance? Maybe Sashikala, you can start.
Thank you for the question. One of the thing was the multi-stakeholder committee, like the formed committee, which has representatives from government as well as local bodies like panchayats, as well as the local community and industries in this case. So they all meet once in not every month or once in 3 or 4 months, 5 months. And if there is an issue, they are coming together to resolve it. So there is I don't think maintenance needs a lot of money, at least for the rural ones, because they are left for it. And whenever there is an issue, then they come together in this all this. And even for Gram Panchayats and this local government bodies, they have money specifically mentioned for restoration or taking care or conservation of these water bodies in their taluk. So there are different schemes, and under that also they have money. So if they have intention of doing it, they can do it. So that was one thing.
So just at an end, you hand over to the government. This becomes the property of the government.
We never take it from the government.
Yes.
So we just help government.
I know.
Yeah. So it is their thing. It is a commons. It is everyone's. So lakes, forests, grasslands, everything we call it as a common. It's the government is just the custodian of that lake.
But an end is an asset. It needs to be maintained. It needs to go even in the budget planning for the government.
Budgetarily, so it's like the panchayat which is taking care of it with the support of all the stakeholders. And we go there when needed. If there is any technical problem or anything, they just reach out to us and we help them. So that's how it is
The
maintained.
basic point you're making is it doesn't cost much to maintain.
Yeah, if it doesn't get deteriorated, then you don't have to maintain
Okay,
it.
we'll have to see it over a few more years, Andreas. That's
even also some other examples, especially the community concepts I know. And I know the limits and also the greatness, but especially from this gentleman, this nice, where also now music bands taking over. I mean, this is potentially how to recover costs of this infrastructure and the operation maintenance. What type of examples we have there?
I'll get all speakers to respond. So Lata, then Usha, and then Akash.
Yeah.
Akash was talking about financial viability.
Yeah, I'd like to know how Akash
Yeah,
manages
yeah.
bigger projects,
Yeah.
because that's more complicated, I know.
He was actually complaining and wailing about it.
Right, okay. So our experience has been, one is of course that when we use nature-based solutions, so you were saying that the amount of money that you need for maintenance is probably much lower as compared to a conventional approach in that sense. So, and whenever there is like a CSR funded project, then most of this, ultimately the pilot projects or whatever are mostly supported by CSR. That's been our experience at least with you. So what we try to do is that we try to build in some money in it to take care of at least the first 1 or 2 years, as I was saying earlier also. Just for the community to start feeling the ownership, and then during that you kind of try, because 2 seasons, I think it's good enough to probably analyze all things that can probably go wrong and all that. And then after that, at least in the Alleppey project that we did and a couple of other projects that we have done, during this process, we try and get the local body also to get involved. And if the project works very well, then they also feel a sense of pride. Then ultimately it is a local body or the local whichever department is concerned who have to pay these people, because any system needs at least 1 or 2 people to be paid on a daily, on a monthly basis or whatever. So in Alleppey and another couple of projects that we have done, we have tried to get the local body to start paying these people. Frankly speaking, it is a challenge, at least from what we have faced, because it's only small money, but then just like you said, changing governments, changing thing, and their priorities keep changing. Somebody comes up with a new thing and all that. And small monies just get delayed by 3 or 4 months. That makes them also feel frustrated. So it's not an easy thing, but I think probably a way would be to, and we also try to see whether there can be like a corpus which can be given to the community and run it. But I don't know, at least in this projects that we tried, they didn't, the CSR didn't kind of give a fund to be given to the thing. I don't know whether there are any legalities with it or not, but that might be a better way is what I would.
Actually, as they have been saying, right from the outset, we have involved our local community completely, right from the point of wanting to save the lake to then getting them to plant trees, etc. So from 2010 to today, our lake maintenance expenses is met purely from voluntary donations that we get from the locality. The municipality takes care of infrastructural support, like if we want to create an intervening bund or things like that, then they put the bill, they create it. But where regular maintenance is concerned, and our lake is small, so we are actually quite comfortable. I am very happy to say I don't have the problems that both of you are facing. So our lake is maintained very well, and I hope that it will always be the responsibility of the community, and that is what we are working at all the time. So we have various ways by which we engage the community and make them feel that they are part of it. Throughout the year, almost every month, we have some program or the other. We have weekend gardening, we bring out a newsletter, we send them email updates. So everybody is in the know of things. When you know and you understand, then you're willing to contribute to it. So yes, we are in a good state right now, and I hope it continues when I'm no longer there or my friends are no longer there.
Say anything about the 500 crore program? The O&M side.
Yeah, so we like what Dhanani's been telling you, we did an expensive project. This was under the Smart City mission. The seed money came from the mission, and but we run it like a business. We don't look for donations. We don't charge people to come into the lake precinct to enjoy. It's free for all. But what we did was in the design, while designing very consciously, I mean, a lot of people think of it as beauty, but each of those facilities that we are creating on the lakeside are being thought of as revenue generating sources. So if
if you come to the lakeside, it's free for you. The cycling is free, walking is free, you can roam around. The minute you want to, like, you're hungry, so there'll be a little restaurant and it'll have outdoor seating. So the actual space given to the guy is just one little container, which also was prefabricated. And a lot of open space for which we charge, meaning he has to pay a lease to the SPV. So under the Smart City mission, there's a special purpose vehicle. The SPV is set up to fund the project, but at the same time, the World Bank and all these people who were advising the Smart City mission at that time, they told them that all this is seed money. We expect you to use it, then generate enough revenue to do the upkeep, and even if you can, then roll the fund over to do another project. So it's pure business. And there's a very interesting book, Eco Square Cities, Eco 2 Cities, or whatever you call it. So economy and ecology. So while we are doing ecology, we are equally conscious of how we need to kind of bring in the money. So in the projects that we have done, there are amphitheaters and there are you saw the laser shows and the boat shows and the jetties and the playgrounds and the event grounds and you name it. I mean, all of it, if you want to use them, will be on hire also. So there's a whole rate list that you can contact the city and you can book your space and do your program. But all that revenue gets ring fenced for the project. That's how we do it.
No, I think, yeah, we're doing pretty well. Are you referring to Coimbatore or some of the projects?
Yeah, so Coimbatore, actually, we drew up a business plan, like what is the kind of expense, and we spent a lot of money. Each lake has a gardener, a garden team, horticulture, we do security, we have monitoring with CCTV. So there's a lot of money that you rightly said, which goes into salary bills and things like that. But at the same time, when you kind of do a whole business plan, okay, this is my expenditure and this is what I will be kind of collecting. So that business plan actually is in the positive. Unfortunately, because it's a governmental kind of a mission, so they didn't roll out as much as we thought should roll out, because they were contemplating, it's like a lot of responsibility. So we have 9 lakes, each lake has like 30 odd things that you can give on lease. So whether it's one operator or you want to give all 30 to different people. So, those mechanisms for them, so they leased out a few things, but a lot of it is now getting leased out to maybe one agency or one private agency, which will take over and then get the revenue and then share the revenue with the government back. So the agreements that they draw up are very tight, and so they measure all the revenue.
Yeah, we are getting some warning on time. So I think Andrew's summary is that the project design built this O&M sustainability ideas into it, but it's sort of half implemented, but not and still being implemented. I think I'll not take any more.
One more, sir. The government also has allocated some money for this prevention of contamination of water bodies in the urban areas.
Right.
So as Madam was telling, Bashetti is also one of the project city selected under the state government.
Right.
So in which we have proposed, there is no STP in that Bashetti. So that lake is being contaminated. So if we construct, here local body has not provided land for that, still they are identifying. If once they give the land, we'll construct STP so that contamination of the lake will be prevented. So like this, we have.
CETP is there.
Okay, I'll interrupt this conversation, sorry. I think.
There is a CETP there in the industrial area, Bashetti Apparel Park. There is a CETP, but the thing is, there is a lot of issues surround, that CETP, it's not being used properly. So if that can be used, we don't have to construct one more STP. So that's.
So under our project, we have proposed one STP.
Okay, thanks for that. I think you can pick up, am I audible? Yeah, you can pick up some of the points in the break now. We're going to have some high tea, I think, right? Just one or two closing remarks before I close the session. Like the elderly gentleman there, I also feel optimistic about the way things are going. 10 years back, we wouldn't have had so many examples to show. And today, in just a handful of 6 people sitting in this room, in this table, dais, you're able to see so many examples. And I'm aware of a good 10 times to 20 times more of these sort of things happening. Very many organizations have produced guidebooks, compendiums, and so on. So, in my career of the last many years, the last 10 years, I've seen tremendous momentum in the area of water body rejuvenation and nature-based approaches also. And a lot of it has been driven by donor-funded money, CSR, and some by government also, but mostly by, the Coimbatore is a big example of how a large government program, and K100 yesterday was a great example of that. So I'm optimistic, and the proof of that is also there in things like the new government programs. If you take Amrit program, there's an Amrit Sarovar scheme. So their earlier government was largely focused on water supply, grey infrastructure, and so on. But increasingly, we find that it's all entering the policy language also. That there is people are focused not just on water supply and engineering, but on water resource management, local water resources management, urban water resources management, and how do you therefore nurture our local water resources. And there is money being made available, like our gentleman from KUIDFC has also been saying that NGT money and pollution control board money and government budgetary supports are being made available increasingly for nurturing, preserving, and augmenting our local water resources. And that takes various forms like this. And that's really good news and positive, and I'm foreseeing that this momentum will only grow. Still a long way to go. And also we see that with people like architects and others coming into this field, it's getting integrated with placemaking, community engagement, public engagement, and so on. And there is a good sustainability model also developing as we speak. And maybe in the next 10, 20 years, we'll see that a lot more cities will look much better with this kind of momentum that's building up. Citizen activism is also increasing, day by day, just like running marathons, people now want to rejuvenate a lake. So there is a lot of traction, for looking after water bodies.
Can I just add one small point?
Yeah, please.
So, looking forward, like I told you, this lake project, we've built it into the design. One of the recommendations we gave Coimbatore City mission was that all the area around the lake, if you can designate as a lakefront zone, because all the property which earlier used to stare at some of the earlier pictures that you saw, the value actually used to be negative. Staying next to a water body which is dirty, your property value would be lower. Now with the lake project, what happens is the same property is commanding a much higher rate in the market. So not only does that kind of increase your value, so the value capture mechanism for that is like we ring that area, maybe 100 meters or 200 meters around the particular project, and every time the property changes hands, so there's a thing called a transaction tax which gets applicable. So you don't have to pay, the owner doesn't have to pay, but every time he's trying to sell it as a premium because of that project, that premium, a part of that percentage of that gets part of the fund. Right. So that's also an innovative mechanism.
Thanks, Akash. With that, we'll close. I think we are running late. Sorry for the delay, all of you who've been patient and waiting. Anushka, you can please close the session.
Thank you so much, everybody, for such interactive and enlightening session. Big round of applause for the session. As a token of our appreciation and gratitude, we would now like to present memento to our esteemed speakers, panelists, and the moderator for sharing their valuable insight with us today. Inviting my colleague Rohini to kindly do the honor. I request all the speakers, panelists, and moderator to stay back for the photograph. Thank you. Thank you once again, everybody. As we conclude day 2, I now request Ms. Sandhya Haribal, Senior Program Manager, CDD India, to deliver the closing remarks.
Good evening, everyone. I'm sure you'll be glad to know that I'm the last person speaking from the podium, basically to deliver the vote of thanks. Such a big event needs inputs from many people across multiple activities. So I would just like to thank each one of them for their contribution to in making this event so successful. I would first like to start with a vote of thanks for the Divecha Center for Climate Change, IIC Bangalore, for being a partner in this event and being so supportive throughout this event. Thank you very much for all your and giving. Second is the most important sponsors, HSBC and Wipro Foundation, without whose contribution this would not have been possible. So thank you very much. We are very grateful to you. Also, our knowledge partner, the Gates Foundation, who has been supporting us for so many years and have also been thoroughly supportive of this kind of an event. Thank you very much. Next is the most important part of this event, the speakers, panelists, experts who came from far away to share their experiences and knowledge. So I would like to start with the international experts who have traveled from far away, from countries like Austria, Germany, Netherlands, Thailand, to be here with us, not just to share what they have done in terms of their body of work, but also to contribute to a lot of engaging communications and debates and discussions throughout this event. So thank you so much, all of you, for bringing in that value into this event. Next most important part were the speakers and experts who have come from different cities in India. We know that yesterday was a big festival, but we are really grateful that you have compromised on that, sacrificed the festival and been with us throughout this event. So thank you very much for bringing in your learning. We have had a huge chunk of papers and abstracts that have been submitted as a part of this event. So I would like to also extend my thanks to all the students and practitioners and researchers who have shared their research or study or project case studies with us. I'm hoping that this would lead to some kind of innovative ideas coming in from this event, and we'll be able to take these efforts forward. Thank you very much. No event or function is complete without good food. So I'd like to thank our caterers, Dhana Teja from High Kitchen, who has worked with us in curating well thought through meals. Of course, they were bold meals, but they were designed in such a way with an intent to keep the water footprint very low, and hence we did not serve meat as a part of the food. So I would like to thank them for that. Also, they've been thoughtful enough to make it as sustainable as possible, and hence, instead of a lavish spread of a buffet, food was served in bowls which were made by sugarcane pulp or bagasse, and this is a very eco-friendly product. So other than that, I would also like to say that we've tried to avoid plastic as much as possible in this entire event, and hence we requested everyone to carry their own bottle or use the water from outside. But other than this, we've also ensured that the kits which were prepared for this event have been made with eco-friendly material. In fact, they've been sourced from an organization called Adivasi, which works with tribal women from Chhattisgarh who make these eco-friendly products. So I would like to also extend my thanks. They have been an invisible part of the event, so my gratitude to them too. And to plan such a big event and do all the work, all the running around behind it, there's been a huge team. I don't want to take the risk of missing out any names. So I would like all my colleagues from CDD and the Divecha Center, please stand up, or if possible, come to the center here so that we know that who has worked, who has been the hands and faces behind this event. May I please request everyone? Come on. Get the news team, please. A round of applause and please keep it continuing. It has been a great effort by everyone, a team effort. Also our CEO, Mr. Harshvardhan. Sir, you've been guiding everyone. We'll have a group photo here, please. And I'm hoping there's not been much of disruptions in anyone's usual routine. We've tried to ensure that the logistics in terms of travel, etc., was taken care of. But I'm hoping everyone was comfortable enough. Thank you, everyone. This has been a wonderful job. Very, very proud to be a part of such a team. Thank you. Thank you, everyone. By the time they assemble for the group photograph, just a small announcement because we've asked about certificate of participation. In the spirit of being sustainable, we'll be emailing the soft copies to all the participants. I hope that would be okay with everyone. So thank you so much for all the patience and being so engaged and involved in the whole event, in every session. Thank you very much. Molly, please come up. So sorry, we still have people trickling in from outside. Sorry. Thank you, everyone. Thank you so much. And we hope that this is just a beginning of a journey, and we do keep meeting regularly to discuss on this important topic and also taking up this to convert into action later. Thank you, everyone. Have a good evening. And just the last announcement, please enjoy the high tea being served outside before dispersing. Just a last announcement, whoever is presenting their paper abstract tomorrow, please assemble here by 9:30. Thank you.